The night holds its breath as if the sky itself senses an arrival. A faint brightening near the morning limb of the sun appears at first like a trick of dawn. The light is ordinary, yet the geometry is not. Something small rides the glare, pacing the heliosphere as a seabird paces a bow wave. No voice announces it. No warning flare marks its boundary. It enters the solar system as most meaningful events enter a life in the periphery, accompanied by the ordinary sound of wind and the soft clatter of instruments that were already awake. Astronomers have a word for objects from the between places, interstellar. It is a word that carries cold with it, cold in the sense of distance and of time stretched thin. Between stars lies a country of almost nothing, and almost nothing is hard to cross. Yet here a crossing completes itself. An object, unclaimed by any planet and unbound by any familiar family of comets, takes a line that does not curve the way heritage curves. Its motion names it as an emigrant. Its brightness names it as ice and dust and sunlight at work. Its timing names it as a story waiting for a voice. Humanity has seen such visitors before, though rarely, and never without controversy. Memory holds a sleek shard that passed without gas, and a fuller comet that fanned itself into a textbook portrait of exile. Those memories set the stage for a third presence. This time the first images show a soft coma that blooms quickly as heating begins. The coma is not theatrical, it is not gaudy, it reads as efficient. It reads as restrained. The mind that watches cannot help but match adjectives to a psychology that may not exist. A name accumulates the way frost accumulates on a window. 3 letters and a slash. Then a word borrowed from a vigilant system that scans the sky for things that might matter. The name feels like the click of a key turning. The name settles the visitor into a ledger that is shared across the world. Yet the ledger says little about intention. The ledger is a census, not a diary. What it catalogues is position and brightness and a whisper of colour. What it cannot yet catalogue is motive. And motive, that dangerous word, rises uninvited like mist at a river bend. If it were only a comet, the heart would still quicken. Comets carry time in granular form. They speak of origin and temperature, and the first chemistry that ever tried to organise itself. They are letters from a childhood that no one remembers. But something about this approach suggests choreography. Not proof, not even evidence, only suggestion. The path seems to use the sun the way a traveller uses a crowd. Slip behind it, let glare turn every eye aside, let heat mask the breath, then emerge changed and farther inward than anyone expected. The possibility rests in the gut like a small bird folded into the hands. The question forms with the slow seriousness of an eclipse. What if the visitor is not only natural, what if it is also made? The phrase refuses to sit quietly. It is too large for casual speech and too fragile for a shout. It must be explored in the rhythm of a vow. The mind begins to weigh what made could mean. Not a machine with antennae and message plaque. Not a mirror with letters cut boldly into its face. Something humbler. Something that could survive long dark and ignore attention. Something that looks like a perfectly reasonable rock until heat finds a seam and the seam answers like a valve. Engineered need not mean hostile. Engineered need not even mean sentient in the way familiar to a nervous species. It could mean designed by a culture cautious enough to look like weather. It could mean shaped by selection, iterated across 1,000 experimental singings of the same song, until the song learned to carry itself between suns. It could mean a seed, but not a seed of life. A seed of method. A seed that proves range is possible for things that begin fragile. If such a seed exists, it would wear a disguise that nature would happily sell it. Ice, dust, carbonic breath, silicate grit. The costume rack of the deep sky. The sun becomes an accomplice without knowing it. As the visitor draws closer, brightness increases. Spectra lengthen and separate like the teeth of a comb. The atmosphere of the object, thin but sufficient, adds its own line work to the song of starlight. Telescopes interpret. Computers compile. Humans who have trained their eyes to read the margins of graphs feel again the old suspicion that their tools are trying to say more than the language allows. There is no proclamation. There is no clean signature. But there is a cleanliness to the way the visitor holds itself together while changing state. There is an economy in the way it vents. In the oldest myths, gods hide in plain sight. They borrow the robes of fishermen and step ashore in shoes that do not squeak. Technology as old as a galaxy would do the same. It would arrive in a costume that registers as boring. It would let its messages ride on forces that do not require apology, like light and gravity and vapor pushed from a warm face. If meaning were present, it would sit low in the noise, protected by the fact that curiosity is expensive and time is short. The visitor feels scripted for such a theatre, and that feeling does not pass. Fear wants to run ahead. Hope wants to run alongside. Discipline asks both to walk. The disciplined voice observes that even the suspicion of design must begin in humility. A faint smear of moving brightness is a poor stage on which to project a civilization. Still, there is a strange dignity in allowing the mind to hold the possibility without clutching it. This is not a declaration. This is an invitation to a careful attention that will stretch across weeks and months, through perihelion and after, as the object brightens, curves, and fades. Somewhere far from instruments, a shoreline experiences a different kind of measurement. People step out before sunrise and squint. They do not see the visitor. They feel instead the escalating romance that arrives whenever a culture imagines itself noticed. Night after night, the idea proves durable. It is less about visitors than about the architecture of wonder. The idea grants permission to speak softly about what survival across distances might require. It encourages patience. It suggests that the quietest arrivals may be the most instructive, because they demand less from the receiver and more from the practice of listening. The solar system itself offers theatre enough for any story, yet the stage feels expanded by the entrance of a thing that did not hatch here. Past the planets lies a long drift of dark granules that circle like uncounted bees. Beyond that, a gulf that outstrips metaphor. This object has crossed that gulf. Crossing is an action that writes character on the one who attempts it. Whether made or born, the visitor is already a masterclass in persistence. Its mere presence compresses years of conversation into a handful of nights spent pointing glass and algorithm at a speck that refuses friendship. He would say it differently, the narrator inside the narrator, if he believed in dramatics. He would speak of a pilgrim whose cloak looks like fog and whose staff is a column of sunlight. He would say the pilgrim chose darkness not out of secrecy but out of mercy, since brightness would have blinded the watchers. He would say the pilgrim arrives with a lesson rather than a warning. But the scientist within him declines poetry at the edge of data. The scientist makes a smaller, stronger vow. Pay attention. Note what repeats. Question what repeats too perfectly. So the opening hours of the encounter belong to patience. The object glides inward. Instruments drink its light and argue in their quiet way. The hypothesis of making sits in the corner like a guest at a wake, who will not leave early and will not speak out of turn. It is neither proven nor banished. It waits for heat to draw out more truth. It waits for geometry to peel away the glare of the sun and grant a profile and a spin. It waits for humanity to remember that amazement is not an argument, but it is a reason to stay awake. If the visitor was made, then arrival is already a message about what time can be asked to do, a message about what fragility can become when it is given tools that fit it like a second skin. If the visitor was made, its anonymity is the first word in a grammar of survival. It says that distance is negotiable and that attention is dangerous. It says that prudence can look like shale and frost. It says approach quietly, then leave no ripples. It says the long game is the only game worth inventing. For now the name is enough, the orbit is enough, the whisper of a spectrum is enough. Let the rest come in its hour. Let the object pass behind the sun, and let every sensor count seconds like beads. Let the hypothesis of design remain a candle, not a fire. It will either gutter in plain air, or it will take on the oxygen of evidence. In either case, the waiting is honest work. In either case, the question has already altered the room in which it was asked. Night on Haleakala begins with checklists and thin air. The small domes of a wide-field survey open like careful eyelids, glass cooling, bearings humming, cables making their quiet promises. The operator verifies weather, sets cadence, then lets automation inherit the night. The system is built for vigilance. It stitches the sky into a grid, visits each tile several times, and hunts for the most fleeting of signatures, a moving fleck that was not there an hour before. The aim is practical, yet the feeling is devotional, a ritual performed for the benefit of whatever chooses to cross the net. The telescope stares with a short focal length and a wide appetite. 30 seconds. A pause. 30 seconds again. Another pause. Then a final exposure to close the set. Between the 4 frames, the stars remain fixed and indifferent, but anything nearby composes a small dance. Software subtracts the stable background and listens for motion. Different images bloom with negative and positive ghosts where nothing moved, and with neat, upright points where something did. Most nights the candidates are noise, hot pixels, cosmic rays that mimic intention for a single heartbeat. Most nights the machine discards its own excitements before a human even sees them. On a pre-dawn hour, one candidate survives the culling. It appears as a clean point in all 4 frames. Not a streak, not a smudge, with a motion that suits the geometry of the night. The measurement script assigns it a score that passes the threshold reserved for things that might matter. In the control room, the operator leans forward, not to touch, only to witness. The moving object processing system gathers the detections into a tracklet and compares them against the known. No catalog entry claims it. The coordinates are pushed to a queue that feeds the minor planet center and the near-Earth object confirmation page. A provisional tag is born, the way a newborn inherits a surname before a first name has been negotiated. Confirmation is the art of asking a question again from far away. Another Atlas station wakes under a different sky, and later that night a second pair of eyes repeats the pattern. Mauna Loa in the archive contributes pre-dawn frames from the previous morning, and those images, already recorded, become Precovery, the cherished find that stretches the time baseline and sharpens the orbit. The halo of observers expands. Pan-STARRS assigns a slice of its night. An amateur in the American Southwest gathers the faintest light with a backyard mirror that has learned discipline. In South Africa, a student at a university telescope works through twilight while baboons call in the ravines. Each team returns a small, consistent motion, a magnitude near the edge of patience, and a point spread function just wider than the seeing would suggest. The earliest orbit solutions are provisional, honest in their uncertainty. With 2 nights, the line through space is a wobble. With 3, the wobble begins to harden. An eccentricity rises beyond the parabolic boundary and refuses to relax. The numbers still wear wide error bars, yet the trend is clear enough to nudge the conversation from local residency to foreign citizenship. The inbound speed, when fit with a simple model, wants to sit a few tens of kilometers per second above escape. The radiant points away from no particular system and toward the undecorated dark between constellations that have never met on a mythic map. The team submits a note to the clearinghouse, careful in tone, plain in detail, the text equivalent of placing a hand on a shoulder and saying, "Please look. Spectroscopy is the next request, a difficult one so close to dawn. The object is small, faint, and swimming in air that never truly settles." A mid-sized telescope steals an hour from a scheduled program, and the slit gathers the smeared breath of a coma that was not obvious in images but asserts itself in the contrast of dispersed light. The spectrum is not rich. It is a lean whisper, a couple of lines where sunlight finds a way through molecules that were quiet in their winter. The detection is preliminary, waiting for confirmation, yet even a thin result directs attention. Cometary behavior, but arriving on a hyperbolic path, is a combination that has precedent yet invites fresh patience. The discoverers decline romance and arrange logistics. A cadence is set that will watch the brightening, measure the rate, and monitor the centroid for signs of non-gravitational persuasion. The world's network of telescopes takes its places without fuss. The lucid rhythm of data begins to fill servers, each file a bead on a thread that stretches across longitudes and cultures. The narrative lives in timestamps and headers, in the way the right ascensions change by predictable amounts, in the steady improvement of astrometric residuals as better calibrations arrive. A discovery credit is a communal act dressed as a line of text. The Atlas team receives the official nod because its pipeline first saw the pattern, and because the follow-up rose quickly enough to prevent the object from slipping back into anonymity. The note that announces this is restrained and precise. It lists station codes and positions, lists magnitudes and skyplane rates, lists the models used for preliminary fitting. There is pleasure in the restraint. Precision feels like a form of respect for the object, which offers nothing but light and movement and still manages to hold attention as if it were speaking. If anyone in the chain allows imagination to race ahead, the place for it is private, not in the record. The record is the lifeblood of trust. It says where, it says when, it says how, and it leaves the why alone. The where is a mountaintop that tastes of salt air despite its height, a site chosen for stability, for the kind of darkness that still survives on an island. The when is an hour that belongs equally to night owls and early risers. The how is a ballet of silicon and glass that humanity now performs as effortlessly as breathing, even though the choreography was hard-won. In the days that follow, Precovery pushes farther back. Archival searches turn up faint traces in data, collected for other purposes. Each edition tightens the orbit like a sailor drawing slack out of a line. The hyperbola keeps its character. The solution migrates within the space of possibilities, then begins to sit still. A press officer drafts a brief that will not overreach. A visualization team renders a simple arc, showing a path that swings in from beyond the planetary family, passes near the sun, and heads outward again. There is no need for embellishment. The shape of the journey carries its own gravity. Ground truth in astronomy is often an absence, a lack of contradiction across methods. Imaging says the coma is compact and symmetrical for now. Photometry says the brightness increase matches sublimation physics at the measured distance. Astrometry says the motion fits a hyperbola with room for a small push from vapor if such a push appears. Each discipline reports without drama, then waits for the others to say the same. When they do, a delicate confidence forms, not a triumph, only a willingness to build upon the foundation without apology. The people involved do not fit a single silhouette. There is the engineer who keeps the time servers honest, for whom a millisecond is a moral standard. There is the observer who can tell from the color of twilight how many frames remain before extinction steals the sky. There is the student who learns, hands shaking, that a 2-meter class instrument has just granted their request for a 10-minute spectrum on an object no human will ever touch. There is the archivist who loves the slow archaeology of old data, who smiles when a faint sequence of pixels aligns with a predicted place and turns guesswork into knowledge. Their names will appear in small print or not at all, but their attention is the invisible scaffold of the story. Long before any public excitement, the system itself has felt the meaning. The cadence is adjusted to keep the object in sight as long as practical. The cue is shuffled. Other priorities give way. The policy that governs such choices is one part science and one part civics. The acknowledgement that sometimes a thing crosses the sky that belongs to all of us. The act of sharing expands. Nightly reports travel across continents. Code snippets for better centroiding pass from one team to another. A subtle pride comes with the knowledge that the planet can still coordinate at the speed of goodwill. The moment of naming arrives with little ceremony. The provisional tag becomes the kind of designation that will live in textbooks and on mugs if interest persists. The letters and numbers do not try to be poetic. They are a kind of vow, an agreement to track, to record, to treat the object as a participant in our understanding, rather than as a rumour. Under that name, data will accumulate with a steadiness that feels like care. Under that name, the discovery passes from the drama of first sight to the discipline of study. There is an old superstition among observers that the sky rewards consistency more than brilliance. This discovery honours that superstition. It emerges not from a grand, singular gesture, but from a patient machine that refused to blink. The first note in the log marks a quiet hinge in the night. The hinge opens, and what follows is built by many hands that will never meet. The instrument returns to its grid and its breathing cadence. The diagram of last night's fields rotates out of view. A new set takes the stage. Somewhere on that wide map, a faint speck moves in compliance with laws that have no preference for origin stories. Somewhere in a server room, the files that hold its light cool to ambient and wait to be read again. 3 is a threshold. In nature, the third appearance turns chance into shape, an outline that the mind cannot ignore. First, a shard that brightened without visible breath, changing speed with a whisper that resisted tidy chemistry. Then, a dusty traveller whose behaviour fit the Book of Comets so well that the book felt newly printed. Now, another emissary crosses the border between stars and sunlight, and the sequence acquires a rhythm. 1 example is an anecdote, 2 is an argument, 3 is a pattern that leans forward and asks to be read. The catalogue offers names like signposts on a narrow road. The first interstellar was tagged 1I and given a gift of a Hawaiian name that means scout, a word that carries the weight of first contact without promising any reply. The second received the 2I mark and the surname of an amateur who caught it from a small observatory, proof that the sky still rewards attention in all its scales. The third inherits 3I and a reference to a vigilant network whose mission is practical, a net designed to see what might bump the Earth, yet equally capable of noticing a stranger who simply passes through. These tags are not poetry, they are scaffolding for memory, a way to hold 3 very different stories in one hand. Comparison is where meaning begins. The first of the trio offered no coma outsiders could see, yet it drifted away from the sun a bit faster than gravity allowed, like a leaf helped along by a breeze too soft to ruffle water. Shape reconstructions vacillated between needle and pancake depending on the chosen model of how it tumbled, a reminder that light curves can sketch but not sculpt. The second was easier on the nerves. It sported a textbook coma and tail, a spectrum rich with familiar signatures, and a behaviour that said cold chemistry is a universal language. It broke apart near perihelion, a fate shared by many comets born near home, and its fragments faded without theatrics. The third arrives with a cloak of gas, visible even at generous distances, a coma that grows with laboratory obedience, yet carries a whiff of imbalance in the mix of molecules that raises eyebrows among those who grew up on solar system recipes. For the third visitor, the proportions matter more than the ingredients. Water is present, as it is almost everywhere sunlight touches old ice, but carbon dioxide asserts itself with uncommon confidence. That presence changes the physics of outgassing, and with it the subtle forces that act like thrusters. CO2 turns on at lower temperatures than water, so the jets can begin to whisper while sunlight is still a low rumour, which gives the object a chance to adjust its posture long before the inner system notices. If someone wanted precise control without the glare of obvious activity, there are worse choices than a propellant nature stores generously in the dark. A trajectory is a confession written in numbers. The inbound speed sits comfortably above escape, neither timid nor reckless. The inclination slices cleanly across the ecliptic, a reminder that the solar system is a parochial plane inside a spherical world. The radiant points toward a region without an obvious parent association, which is to say the sky refuses to sign the visitor's letter of introduction. All of this is ordinary for an interstellar body, yet pattern-making minds observe that, with 3 objects in hand, a spectrum of behaviours is beginning to show itself. One dry and puzzling, one wet and familiar, one wet but oddly composed. Does the spread map nature's chaos, or the optimization curves of designers trying different answers to the same hard question? Statistics enters as the sober friend who checks the doors before sleep. 3 is not many, yet it is enough to tempt the machinery of inference. Detection biases play a dominant role. Wide field surveys have grown quicker and deeper, which favours discovery of comets that light themselves generously. Dry visitors the size of cargo containers may pass unannounced every season, leaving only a rumour of altered trajectories in the archives. Large, gassy arrivals are far easier to count. The third object may simply be the easiest kind of interstellar thing to notice. Even so, scientists lay the 3 on a table and trace the curves with their eyes, hunting for a hidden regularity that would suggest someone else has been drawing these arcs with purpose. The calendar has its own poetry, a first in 2017, a second in 2019, a third now, the intervals not periodic, yet close enough to feel like the heartbeat of a maturing capability. Surveys that promised a harvest are making good. The sky is yielding to patient automation and human attention braided together. As the count grows, the question of engineered intent must endure a stronger test, because nature is a prolific tinkerer, and randomness with constraints can imitate choice with unnerving fidelity. Still, if intention hides anywhere, it would hide in the parts of the light that ride below casual thresholds, in the small accelerations that recur with suspicious rhythm, in the way an object hugs the shadow of the sun at moments that maximize concealment. Material choices leave signatures, faint but real. Dust grains scatter sunlight according to size and composition, so polarimetry becomes a kind of fingerprinting. If the third visitor carries an unusual distribution of grain sizes, skewed toward a narrow band that maximizes radiative cooling or confuses certain wavelengths, an explanation will be required. If that distribution repeats over time more precisely than a natural outburst would allow, the case for craft grows teeth. Even then, sober voices insist on geology first. Thermal fracturing can be remarkably consistent when an object rotates with just the wrong period. Sublimation fronts migrate and stabilize according to topography that no eye has seen. The third example invites the most careful campaigns because the sample size has finally earned the attention spent on nuance. Names of instruments circulate in careful whispers, high-resolution spectrographs that can separate a tight carbon dioxide band from a crowded background, mid-infrared cameras that catch the warmth of grains when sunlight presses too insistently, adaptive optics that claw an extra half-arc second of detail from thin air. Time on such tools is precious, but a third interstellar arrival unlocks doors. Proposals move from speculative to urgent because each visitor rewrites a few lines in the shared textbook of origins. No mission can fly to meet this one, yet a fleet of photons already in transit will carry its story if collected with discipline and interpreted without drama. The human response evolves alongside the dataset. With the first, astonishment dominated. With the second, relief and curiosity held equal shares. With the third, curiosity matures into method. Observers distribute tasks like musicians dividing a score, each instrument handling a register suited to its strengths. The rhythm of observations becomes metronomic, a heartbeat endured and cherished. Public excitement grows, ebbs, and returns on its own tides, but within the quiet rooms the feeling is steadier. There is work to do, and the work itself is an answer to the ancient request for meaning. Across these three examples, an unasked lesson emerges about survival. If natural, they tell of systems forming in cold and chaos, of debris travelling far, of chemistry robust enough to echo across gulfs. If engineered, they describe a playbook that values subtlety over spectacle, redundancy over bravado, and the anonymity that comes from looking like weather. The third object, by merely existing, sharpens both stories. It forces the models to grow up. It pressures the dreams to choose constraints. It invites humility without demanding silence. The label 3, I will live as long as the ark remains in archives, a small set of characters that mark a moment when a sample size took its first credible step away from anecdote. The object itself will leave as all such visitors leave, following the arithmetic of ellipses unclosed, carrying in its coma the subtlest hints of choices made long before sunlight found it. In the wake, there will be papers and arguments, and the soft gratitude that attends any honest look at reality. 3 is a threshold. Beyond it lies either a forest of wild growth or a garden designed with care. The next arrivals will decide which image fits. For now, the third interstellar holds its line, and the pattern it completes glows just bright enough to keep watchful people awake. Chemistry arrives as music. A slit across the faint coma turns light into a score, and each bright line is a note played by a molecule that has just met the Sunday. Analysts read the staff with monastic patience. A violet whisper around 388 nanometers tells of CN radicals set free from parent organics. The green flare near 557.7 nanometers is forbidden oxygen, a delicate afterglow from atoms unbound by sunlight. The swan bands of C2 ripple across the visible like a chorus of low strings. In the near ultraviolet, OH at 308 nanometers flickers as the earliest proxy for water. Farther into the infrared, where air on Earth is restless and greedy, the signatures of carbon monoxide and carbon dioxide try to carry through with difficulty. Atmospheric lines bite at them, Yet careful subtraction still leaves a story to be read. The first surprise is proportion. In the vocabulary of most comets, water dominates as heliocentric distance shrinks. Here, carbon dioxide speaks with an authority it rarely enjoys near the orbit of Mars. The ratio of CO2 to H2O, inferred from the interplay of oxygen's green and red lines, leans toward carbon dioxide so strongly that the modeler checks calibration twice, and then again. It is not a violation of physics. It is a preference written into ice. Carbon dioxide sublimates at lower temperatures than water, so a nucleus rich in it can begin to breathe while still far from warmth. Yet the vigor feels curated, the balance of volatiles tuned to turn on early, to create a shroud before the more easily noticed species awaken. Dust participates with its own dialect. Polarimetry measures the way scattered sunlight twists and fades, reporting grain sizes and textures as if sketching fingerprints. The phase curve, brightness versus angle, looks unusually tight, as though most grains share a narrow size band optimized for radiative cooling. That narrowness can emerge from natural processing, especially if an object has tumbled through gentle heating cycles for ages. It can also emerge from intentional selection. A cloak made of grains tuned to hide thermal contrast and mute spectral edges would be a clever garment for an object that prefers to be background. Isotopes enter the conversation like auditors. Deuterium in water compared to ordinary hydrogen tells of temperatures during formation. Nitrogen's heavier sibling within CN hints at the chemistry of the nursery. Carbon's ratio in CO and CO, two record stages of synthesis and exchange. If the numbers sit within solar system norms, the case remains simple. If they drift, investigators ask whether exposure to cosmic rays or long sojourns in the interstellar medium could have shifted the balance. A deliberate process could also shift it. Refining ices to favor certain isotopes changes sublimation behavior and cooling efficiency by small amounts that add up across millions of seconds. Even a few percent deviation, if consistent across species, would suggest someone once cared about how this body would breathe. Trace chemistry offers additional puzzles. Ammonium salts can stabilize volatiles and soften the violence of outbursts, a fact learned from a comet that shed peppery dust with surprising gentleness. If similar salts appear here, their ratios to parent molecules might reveal a recipe written to suppress spikes. Halogens, rarely generous with their signatures, can nevertheless betray themselves via faint lines from HCl or HF when sunlight becomes intrusive. A trace of organosilicon would be stranger still, a whisper of polymer hardeners that do not belong in natural ice unless complex prebiotic chemistry went very far in the cold. None of these detections alone would prove intention. Taken together, coherently skewed away from the usual kitchens of planetesimals, they would start to sound less like accident and more like design. Thermodynamics clarifies motive. Carbon dioxide is both curtain and propellant. As a coolant, its sublimation robs heat while building an insulating coma, letting the core stay cold and mechanically quiet. As a gentle thruster, it can produce steady, low-noise acceleration that hides inside the expectation of cometary jets. The vapor pressure curve is friendly to fine control at large distances, where water would sleep and CO would be too eager. If the nucleus holds porous matrices or clathrates, cages that trap molecules until a threshold is crossed, venting can be made almost metronomic. To an outside observer, periodicity in gas production might look like a rotating patch of active terrain. To an insider, it could be a deliberate pulse train, a flywheel made of vapor to trim attitude without shouting. The coma's chemistry changes with distance in ways that repay attention. At 5 astronomical units, the spectrum leans on CO2 and CO, with OH hard to separate from noise. At 3, OH strengthens, but the oxygen green line still overperforms. By 2, classical water pathways should dominate, yet here, the carbon dioxide refuses to yield as much as models predict. The gradient feels engineered for continuity. Instead of a sharp handover from carbon dioxide thrust to water-driven activity, the two share the stage for longer than necessary, smoothing talks and preserving a stable illumination pattern on the surface. If the nucleus harbors structures sensitive to thermal stress, Such smoothing would reduce cracking and keep the geometry of venting clean. Dust-to-gas ratio matters for mechanics as well as aesthetics. A dusty coma absorbs sunlight and remits in infrared, warming itself and changing how forces accumulate. A gas-heavy coma allows more direct control, with pressure waves traveling cleanly from vent to void. Measurements point to a relatively dust-poor environment given the brightness, as if the source regions favor gas release without ripping up grains. That favors durability. Natural terrains can do this, especially if mantled by sintered crusts, but the consistency over rotation cycles impresses even skeptics. Regularity here is not proof of anything human-like. It is simply good engineering, whether produced by glaciers, a vacuum, or a workshop. If intention hides in composition, signal could ride inside a minor species. The coma is a radio that cannot be turned off, yet it speaks in thermal logic rather than binary tones. A pattern of small modulation in a line's intensity, phased not to rotation but to solar vector, could encode a timetable. Fluorescence efficiencies vary with heliocentric velocity as well as distance, giving designers a knob that nature rarely adjusts so cleanly. An object that very slowly shifts the proportion of two faint lines in a way that maps to prime numbers or a constant would be performing a risky but elegant act of conversation without transmitters. Searches for such games require patience, excellent calibration, and a refusal to see messages in ordinary weather. Nevertheless, the temptation to look is honorable. Remote sensing sets limits, but chemistry also lives in light curves. Broadband colors evolve as the mix of grains and gases changes. If certain filters brighten in lockstep not just with distance but with a separate clock, one might infer timed releases. Narrowband photometry centered on CN, C2, and OI can trace the heartbeat of production rates in an almost physiological plot. Plateaus where nature usually jitters would be notable. Ramps and stairsteps would be stranger. Each of these subtle shapes has natural explanations. Subsolar points wander. Self-shadowing cliffs open and close vents with rotation. Yet the accumulation of tidy behaviors across several diagnostics would keep the question alive. Finally, there is the possibility that chemistry is camouflage. A nucleus wrapped in purpose might carry small stores of absorbers tuned to hide unusual materials beneath. Fine-grained amorphous carbon is excellent at swallowing curiosity, and sulfide dust can muddy spectra with ease. Adding a little too much iron could push polarimetry toward ordinary numbers. In such a case, anomaly would live not in presence but in absence, a suspiciously generic portrait painted by a process that usually leaves regional quirks. Uniformity becomes a flag. The coma that always looks like a catalogue plate begins to feel like a mask. All these lines of thought remain accountable to the data. Exotic explanations only deserve airtime if simple models stumble. Here, the allure lies in the way the ratios, the rises, and the refusals to spike seem to hang together. A comet can be eccentric in one or two traits without comment. A visitor that is coherent in its oddity earns a harder stare. Chemistry is not gossip. It is a ledger of exchange written in photons. If that ledger shows careful budgeting of volatiles, deliberate smoothing of thermal shocks, and a bias towards species that enable quiet thrust and deep shade, then speculation steps forward with humility. Perhaps the ice is a habitat for something sleeping. Perhaps it is a courier with a cargo of memory. Perhaps it is an instrument designed to measure a star's breath from inside the star's attention. The sun will keep reading the score as distance changes, teasing new timbers out of old molecules. The spectrum will lengthen, lines will sharpen, and curves will reveal discipline or disorder. The chemical story can stand on its own, a meditation on how materials choose to change shape in light. Yet the possibility of intention remains an undertone, a bass note that gives the melody weight. To listen for it is not folly. It is a way of honoring the music by admitting that sometimes a song sounds arranged. Trajectory is a kind of handwriting. Planets trace circles with the patience of monks. Comets sketch long commas that brighten as they curve through heat. Interstellar bodies write in straight strokes that bend only once, a single syllable spoken to the sun and then withdrawn. Within that grammar, small choices speak volumes. Inclination is accent. Argument of perihelion is rhythm. The longitude of an ascending node is the place in the sky where a sentence takes its breath. Read carefully and geometry begins to resemble motive. The incoming vector arrives from high celestial latitude, gliding across the solar system's thin disk like a swallow cutting a pond. Such an angle refuses the comfort of the ecliptic and the tangled help of planetary assists. A path that stays clear of the giant planets avoids surprise. Jupiter is an instrument of fate for the unwary. A corridor that misses its reach by a generous margin is a signature of prudence. In a universe that rewards caution, a prudent path feels less like falling and more like arriving on purpose. Solar elongation turns detection into a timing game. When an object rides a long season of small elongations, it shares the sky with dawn or dusk, where instruments labor against air, glare, and geometry. Wide-field surveys thrive near opposition, where targets sit opposite the sun and the sky is generous. By choosing a corridor that holds elongation down near the edge of comfort, a visitor can trade brightness for concealment. Days slip by with only a few narrow windows for measurement. The watchers adapt, but every adaptation costs motion that can never be recovered. If stealth were a parameter to be optimized, this is what the solution would look like. Perihelion distance is a thermostat disguised as an orbit element. Set it too tight and the object cooks, shedding mass in panic. Set it too wide and the coma stays thin, starved of sunlight. A sweet spot exists where volatiles wake without rage, where a shroud forms quickly, but the nucleus remains cold enough to keep its structure. That distance also controls how long the object spends near the sun from the point of view of Earth. A shallow dip can minimize days with clean geometry, compressing the campaign into a sprint. A deeper swoop trades heat for a longer stare. The chosen value reads like a decision carved into space. Speed at infinity is a character trait. At tens of kilometers per second relative to the sun, a traveler cannot be captured absent miracles. Within that speed lies another choice. A higher value shortens the time spent in the inner system. A lower value gifts astronomers weeks they would not otherwise have. Natural origins offer a distribution set by the motions of stars and the mechanics of distant ejections. A crafted courier could bias its V-infinity to meet a mission clock. Time in sunlight is hazard and opportunity in equal measure. The curve drawn here looks like someone balanced those two columns on a ledger, then chose the number that left both sides quiet. Non-gravitational acceleration hides in the fourth decimal place of a residual. Fit a hyperbola to 1,000 careful astrometric points, then study what is left. A small radial push can masquerade as the sigh of sublimation. A tiny transverse component can trim the path like a rudder. An even smaller normal term can hold a plane against drift. Marsden-style parameters, A1, A2, A3, were invented to account for such whispers. Nature can populate those coefficients in a messy way. Engineering would favor steadiness. If the signs stay constant across weeks, if the amplitudes scale cleanly with distance, if the normal term refuses to wander, the handwriting begins to look like a practiced hand. Rotation couples to path in ways both subtle and grand. Venting from a fixed patch produces thrust that turns with the body, a periodic nudge drawn onto an already elegant arc. Depending on the phasing, the average push can aim slightly off radial, providing control without spectacle. The careful reader looks for aliasing between light curve period and the period inferred from slight curvature changes in the track. When those clocks align too politely, suspicion grows. A natural body often jitters. A designed one would prefer clocks that keep promises. There is also the quiet art of planetary avoidance. The B-plane, that imaginary canvas perpendicular to a planet's approach vector, records missed distances like the margin notes of a diligent student. For an object that passes through the inner system, 3 B-planes matter most, those of Earth, Venus, and Jupiter. A path that threads between them with casual generosity may be accidental. A path that places the mispoints near regions of minimal deflection looks like someone knew the map. Less deflection means fewer surprises on exit. Fewer surprises means a safer return to interstellar night with the cargo intact, whatever that cargo might be. Solar cycle influences the choice of season. Extreme ultraviolet radiation swells and shrinks with the 11-year heartbeat, changing the energy budget of any surface that walks near. An arrival timed for quieter solar weather reduces outbursts, keeps coma pressure smooth, and hides non-gravitational signatures inside gentler chemistry. Conversely, a peak in activity can be used as a veil, burying deliberate adjustments beneath natural storms. The chosen calendar date is a knob that can be tuned by a patient mission planner. The sky keeps its own rhythms. A traveller that listens reaps the reward of invisibility. Observers look for geometry that tells on itself. A path that skims just behind the sun from Earth's vantage for a suspiciously long arc is a red flag, because the glare robs the planet of its most capable eyes. That same geometry grants prolonged coverage to spacecraft at off-Earth baselines, but those instruments are fewer and often committed elsewhere. An object that anticipates the blind spots of a biosphere and inhabits them demonstrates an understanding not of physics alone, but of the culture of physics as practiced by apes with cameras. That understanding, if present, is the purest hint of intention. Consider the exit. A clean outbound trajectory that avoids resonances with the planetary system helps memory remain intact for any recorder riding within. Resonances can amplify tiny uncertainties into chaotic divergence over decades. A planned path would stay clear of those shoals. It would also aim outbound towards sparse stellar fields, easing glare subtraction for anyone who later studies the wake. Thoughtfulness toward the future observers who will read the trail is a curious hallmark of kindness in design. Kindness is a luxury in deep time, yet it sometimes appears where no one expects it. Even in a purely natural reading, the same geometry teaches, gravity is not a tyrant, but a landscape. High inclinations and careful perihelia tell of birth environments and long wanderings. Non-gravitational residuals sketch the breathing of ice in sunlight. Missed distances from the giants mark either luck or ancient scattering events. The map contained in the orbital elements is a fossil of forces before any human chose to care. To study it is to learn the language written on the bones of motion. If intention is permitted as a hypothesis, then this is the quietest possible proclamation. No transmission, no beacon, only a line drawn with such restraint that the signature hides inside the elegance of the solution. Enter where the eyes are weakest. Turn at a distance that keeps the core intact. Nudge gently in directions that look inevitable. Leave along a slope that minds will find hard to climb. The story of such a trajectory is not drama. It is craft. It is the art of moving through a watched room without stirring the curtains. The watchers respond with their own craft. They fit models that assume nothing, then models that allow for breath, then models that admit a sliver of steering. They compare seasons, elongations, and skyplane angles, folding the data back onto itself until systematic errors confess. If the residuals hold a rhythm they cannot explain, they will not rush to romance. They will write the numbers anyway, because numbers are how humility speaks. And humility is the only stance that makes sense when reading a sentence written across the sky in a script older than language. Perihelion is a curtain of light. The sky brightens until it ceases to be sky, and the sun fills every imperfect surface with scattered brilliance. In that white ocean, a small traveller can vanish without moving at all. Silence is not only absence of sound, it is the subtraction of a thing from the field, where instruments know how to look. A body that steps behind the solar glare acquires a kind of diplomatic immunity. Telescopes that are fearless at midnight become uncertain in the treachery of dawn. Sensors that count single photons surrender to a flood. The object does not need to hide. The star does the hiding for it. Geometry does the rest. Solar elongation shrinks toward angles that make astronomers squint. Low elevation forces light through heavy air. Dust and humidity turn the atmosphere into a lens that nobody ordered. Baffle edges in camera housings glow from internal reflections. CCDs reach their full wells early and misbehave. Calibration frames taken at night do not apply when the dome is awash with scattered day. The most diligent pipelines become cautious in this regime. Detections fall below thresholds built to protect against false alarms. If concealment were a design goal, this is the moment a path through the inner system would be timed to exploit. Specialized eyes attempt to compensate. Coronagraphs carve artificial eclipses, placing a disk over the sun so that a faint corona and anything embedded within can be recorded. These instruments are triumphs of subtraction, yet they have limits set by their optics. The inner working angle defines how close to the sun a trespasser can be and still be resolved from the blaze. Stray light from dust on the occulter or micro-roughness on mirrors creates a forest of ghosts. Cadence is optimized for coronal dynamics, not for precise astrometry of a point source slipping through. Wavelength bands are chosen to read plasma, not to weigh dust and gas. The data are invaluable, but they are not designed for this particular mystery. Physics near the star is unforgiving. Radiative heating climbs with the inverse square of distance, and thermal skin depth shrinks so that only a thin layer of material feels the day. Sublimation spikes as molecules find their vapor pressure and flee. Dust aggregates release and collide, then mince into sizes that feel radiation pressure like wind. Forward scattering surges as the phase angle favors glints. Observers might see a brightness increase that misleads them about mass loss. The coma can thicken without confession, not because a hand has placed a veil, but because sunlight writes its own persuasive story on every surface it touches. A careful traveller could use this violence as cover. A composition rich in carbon dioxide would begin venting while still far out, building a soft shroud early. Near closest approach, if the matrix is porous and the vents are small, the gas can regulate itself. Pressure balances against sintered crust. Jets blur into a nearly isotropic breath. The torques that often jolt natural nuclei lose their edges. Photometry becomes steady rather than flickering. Light curves flatten. Spectral lines broaden gently instead of lurching. Regularity is hard to prove when instruments are half blind, and a quiet rhythm can disappear entirely under the sun's unkind halo. Plasma adds an additional layer of silence. Radio waves crossing the corona suffer dispersion and scintillation. At certain frequencies, the plasma frequency itself blocks passage. A transmission that could sing across the outer system might be smothered within a few solar radii of the disk. If a device aboard preferred to avoid exposure while in the worst of this weather, its best option would be simple: do not speak. Let gravitational motion carry the message of presence. Let non-gravitational nudges, if any, be small enough to drown in the ambient storm. A period of intentional radio quiet would blend seamlessly into the natural radio noise that the sun provides at no charge. Even without transmitters, a body can leave a pattern for readers who know where to look. Grains released at particular times trace syndines and synchrones that encode their moments of escape. Models like Finsen-Probstein turn those patterns into clocks. Near perihelion, the tails and trails become confused by severe geometry. Radiation pressure drags small grains into fans that wrap around the sun from our point of view. Lorentz forces can tug charged particles onto strange paths. Disentangling these motions demands viewing angles that ground-based observatories can rarely maintain when the elongation shrinks. Spacecraft that can see sideways help, but allocation schedules and health constraints limit how long they can stare. Thermal engineering becomes biography. Conductivity, heat capacity, and porosity determine both how an object suffers and how it remains intact. A nucleus with high thermal inertia absorbs energy without catastrophic gradients. A surface that radiates efficiently sheds excess heat without relying on desperate outgassing. Clathrates store molecules in cages that release as thresholds are crossed, providing a buffering against spikes. These are the tools of glacial physics. They are also the tools of prudence for any structure that must encounter a star regularly. If the traveller is natural, it teaches how ice learns to be strong. If it is designed, it demonstrates a preference for steady-state dynamics over drama. During closest approach, time itself becomes thin. Opportunities to measure are counted in minutes snatched from the shoulders of daylight. Schedules at observatories bend and sometimes break, but the window remains narrow. The loss of a dozen frames can mean the loss of an entire rotational phase. The growth curve of the coma passes through its steepest slope when detectors are least able to keep pace. Outbound, the same curve softens exactly when equipment returns to comfort. The asymmetry is an artifact of the vantage point, not necessarily of the visitor. Misread by haste, it can look like a change of behavior that never occurred. There is a temptation in such periods to widen the search for signals that the bright background cannot easily smother. Gravity is one. Tiny adjustments to track curvature, if measured with sub-arc-second reliability against a mesh of reference stars, can reveal impulses otherwise invisible. A cautious analyst plots residuals and finds them dominated by systematics from glare. This is not failure, only a reminder that ambition must bow to conditions. Another temptation is to look for structured polarization in scattered light, a fingerprint of grain alignment. Near the sun, however, multiple scattering and instrumental crosstalk grow mischievous. A pattern seen at noon can vanish at night, not because the universe changed, but because the instrument remembered its own imperfections. The sun itself becomes a collaborator in the erasure. The corona shimmers with loops and plumes that evolve on timescales of seconds to hours. Moving features can masquerade as moving points. Compression fronts detach and race outward, dragging brightness with them. Helmet streamers and pseudo-streamers braid like hair in a wind that nobody feels. Within this living background, a point source needs to be stubborn to remain obvious. And few are that stubborn. For the brief passage through this field, modesty becomes indistinguishable from prudence. After closest approach, the universe regains its usual contrast, and the data begin to thicken again. Inferences about what happened near the star must be reconstructed from the flanks of the event rather than from its heart. That is not a flaw in method. It is the archaeology that astronomy often performs, reading voids as carefully as stones. If a body planned to keep a secret, timing it so that the hottest hours were also the least observable would qualify as competence. If a body simply followed the physics that shaped it long ago, the same coincidence would occur, because the sun is generous with cover when one most needs it. The lesson of such a silence is not paranoia. It is respect for the theatre where the measurement takes place. Perihelion is a hall without seats, a blaze where human senses falter and machines bear the weight. In that hall, even a modest traveller can pass without leaving a clean line on the page. To notice this is to understand that absence can be as diagnostic as presence. A gap is not empty. It is the shape of the star carved into the story. Anyone planning a crossing between suns would learn this quickly. Anyone studying such crossings learns it slowly and then forever. Sublimation can be a disguise as clean as snow. Ice near vacuum does not melt into puddles. It leaps straight into gas and carries dust with it, and that breath becomes a curtain. Seen from afar, the curtain is a coma, a soft sphere of scattered sunlight whose brightness falls with distance from the heart. Within that glow, the true surface hides, blurred by photons that have been forced to bounce in all the wrong directions. The mask is not opaque, it is merely sufficient, a fog tuned to the exact thickness where shape and texture dissolve into generality. Camouflage begins at the smallest scales. Grains stripped from a surface inherit the architecture of their parent terrain. If those grains are fluffy aggregates, webs of submicron filaments with a fractal character, they present an enormous cross-section for light without adding much mass. They scatter with a forward bias that can increase glare near high phase angles and dim reflection toward the observer when the geometry changes. Tiny shifts in composition alter the complex refractive index, which nudges the balance between absorption and scatter. Amorphous carbon drinks light and becomes warmth. Silicate flakes throw light away like a school of fish turning in the sun. Tholin-rich mantles add a red tilt that many primitive bodies already share. A designer who wished to blend in would select mixes that recreate the most ordinary colors, then grind or grow the grains to a size distribution that erases edges and keeps the coma smooth. Gas plays its own part in the deception. Carbon dioxide and carbon monoxide launch the flow at distances where water would sleep, laying down a diffuse sphere long before strong heating begins. As water wakes, its fragments add CN and OH lines that every comet wears like a uniform. The overlapping bands fill the spectrum with familiar features. Any faint signature from unusual materials riding deeper inside must then compete with a forest of ordinary light. Even in high resolution, the lines crowd and blur, and telltale narrow features drown in a choir that was tuned to overwhelm. Density profiles complete the costume. A classic coma follows simple rules, number density decreasing roughly as 1 over distance when outflow is steady and isotropic. If vents are numerous and distributed, the superposition of their streams can approximate that rule to remarkable precision. A deliberate architecture of pores, channels, and micronozzles could maintain steadiness even as the star rises and sets across the rotating face. Self-regulating valves such as clathrate layers would act as governors, opening when temperature reaches a threshold, closing as local pressure drops. To an observer who fits models, the result is a comfortable curve that matches expectation within errors, and comfort is the most reliable cloak in any science. Torque hides in the cloud as well. Jets push, and that push would usually imprint a periodic signature as rotation brings active areas in and out of sunlight. If the active terrain is arranged in complementary pairs, or if small vents are phased so that their impulses cancel over a rotation, the sum looks like a steady radial drift rather than a wobble. Natural landscapes can mimic this symmetry by accident. A cautious maker would insist on it by design. The coma then becomes a propellant field that whispers rather than shouts, and astrometric residuals fall into patterns that no one is eager to call suspicious. The mask also confuses size. Photometry measures brightness and infers a nucleus radius from how much light could be scattered or emitted if the surface were sunlit and bare. A bright coma adds a pedestal under every measurement, smearing the point spread function, hiding the hard edge that would allow a clean separation. Proxy quantities such as AFRO translate coma brightness into a stand-in for dust production, but that number can be made to match 1,000 possible bodies. A small core with efficient dust lofting can masquerade as a larger core with lazy vents. Shape models built from light curves become slippery, because a thick coma fills in rotational shadows and silences the contrast that reveals orientation. Radiative transfer turns the fog into strategy. An optically thin coma lets starlight reach the surface, where it drives sublimation with local vigor. An optically thicker coma shades the nucleus and moderates heat spikes. By holding the optical depth near unity, within a few tens of kilometers from the center, a traveler can keep surface temperatures within safe bounds, reduce mechanical stress, and slow mass loss without turning off activity completely. Such tuning could arise naturally if surface layers evolved toward porosity and sintering. It could also be cultivated, with reservoirs placed under insulating crusts and vent throats designed to maintain a target column density across a range of solar distances. Scattering physics offers further tools. Hollow spheres and core mantle grains exhibit resonances that sharpen or flatten polarization curves. Polarimetric measurements then read as if the dust were ordinary, even if the internal structure is not. Aligning non-spherical grains with weak magnetic fields can produce distinctive polarization, but a gas-rich environment and mild turbulence quickly randomize orientations. If the goal is to look like everything else, a turbulent, gas-dominated flow is an ally. There are forms of concealment that aim at other wavelengths. Millimeter and centimeter waves can probe lower into a cloud, and radar can sometimes glimpse a nucleus through dust. Gas laden with electrons from photoionization scatters radio waves and introduces phase noise. Small charged grains respond to Lorentz forces and create filaments and curtains that are transparent to visible light, but noisy to radar. A cloud thick in low-mass grains becomes chaff for the long wavelengths that would otherwise reveal bulk properties. None of this requires exotic technology. It is what plasma and illumination do together when given a little density and a little time. The chemistry of veiling has subtler chapters. A trace continuum from very small grains heated to high temperatures can fill the gaps between emission lines and soften slopes. Sodium and potassium release narrow lines that draw attention, yet they can serve as decoys if their production is modulated by sunlit geometry. The eye goes where it expects to find story, and the rest of the spectrum fades into backdrop. Even fluorescence itself can be steered within modest bounds. Pumping efficiencies depend on the relative velocities between sunlight and molecules, and careful control of gas temperature and outflow speed nudges, which rotational branches dominate. The result is a familiar pattern with a slightly different emphasis, tuned to hide what sits beneath. Motion is part of the mask. A cloud that expands at a few hundred meters per second carries grains away from the source fast enough to blur origin, slow enough to remain in the neighborhood, long enough to thicken the shroud. Radiation pressure then sorts grains by size, pushing the fines outward and letting the heavies linger close. By selecting a production rate that feeds the preferred sizes, the cloak refreshes itself continually while keeping the inner optical depth stable. Meanwhile, the steady leak carries away reaction products and trace species that might betray odd materials, letting the environment reset to a bland average before anyone can catch a spike. All disguises fail if they draw attention by trying too hard. The elegance here is restraint. No dramatic jets, no violent outbursts, no bright sodium tails that would invite curiosity. Just a patient fog that looks like a page from a familiar atlas. The face beneath can then be anything that benefits from shade and anonymity. A vault with fragile cargo. A laboratory that must sample near-star wind without contamination. A recorder that prefers not to be sandblasted. Or simply a natural crumb of a long-destroyed world, outfitted by physics alone with the same quiet clothing because all survivors of heat eventually learn to dress alike. What matters to the watcher is that sublimation, so often treated as a nuisance to be modelled away, is in fact a language. Pressure, temperature, porosity, and sunlight form its grammar. Dust and gas supply its vocabulary. Read properly. The sentences carry information about intent, or about the absence of intent, a coma that keeps perfect time, a veil that maintains the same thickness across rotations and distances, a palette of molecules that never wanders far from the median. Each line of behavior speaks. Hearing meaning in those lines requires discipline. Not every tidy curve is a confession. Yet if caution is a virtue, a body that writes caution into its very exhalation cannot help but make minds lean forward. Ice can be an engine if patience is the fuel. Sunlight touches a frozen surface. Molecules unhook from bonds. Gas escapes into vacuum, and momentum flows the other way. No bell, no turbine, no roar. Only a whisper of vapor that carries thrust as surely as any plume of fire. In free molecular flow, where collisions are rare and paths are long, the exhaust velocity of a molecule depends mostly on temperature and mass. Water at a few hundred Kelvin leaves at hundreds of meters per second. Carbon dioxide departs more slowly, yet offers a smoother throttle at lower heat. Carbon monoxide leaves faster, at the price of being difficult to store in abundance. Each species writes its own chapter in the Book of Gentle Pushes. The equations are simple and merciless. Force equals mass flow multiplied by exhaust speed. Acceleration equals force divided by total mass. A small example clarifies the scale. Imagine a nucleus with a radius of 50 meters and a bulk density near 500 kilograms per cubic meter. Its mass would be on the order of a few times 10 to the 8 kilograms. To impart a microacceleration of 1 part in a million meters per second squared, the required thrust is a few hundred newtons. With an exhaust velocity of 300 meters per second, the mass flow would sit below a kilogram per second. Sustained for a month, the total loss would still be a modest fraction of the whole. The numbers point to a paradox that is not a paradox at all. In the deep quiet of space, a very small wind can move a very large stone. Control begins with where the gas escapes. Vents placed near the subsolar line will fire hardest, since they receive more heat, while vents in shadow will rest. By distributing many small throats rather than a few dramatic geysers, the sum can be tuned to produce a nearly constant push in a desired direction. Porous matrices behave like millions of nozzles at once. Narrow channels keep flow laminar, reduce turbulence, and prevent chaotic torques. If the network also contains microcavities that act as reservoirs, the release becomes buffered. The result is thrust that changes slowly, in step with solar distance and local time, not in violent fits. Heat is the real propellant, and heat can be steered. Surfaces that switch albedo act like valves. A patch that darkens under ultraviolet loads more power into the underlying ice, while a brightened patch relaxes. Thin film shutters, reflective louvers, and variable emissivity coatings can all move joules from one region to another without pipes or pumps. Even natural terrain can perform this trick if fractures expose fresher material that has different optical constants. Engineering would add conduction paths and thermal diodes so that warmth flows preferentially along chosen gradients. A traveler then trims its thrust vector by trimming its light. There are subtler engines hiding in the pores. A temperature gradient along a capillary can drive gas from cold to warm through the Knudsen pump effect, a kind of molecular ratchet that needs no moving macroscopic parts. Arrays of such channels create a network of steady microflows that persist as long as sunlight keeps one end slightly warmer. At the throat, free molecules accelerate into vacuum, and the aggregate reaction nudges the body. The magnitudes are small, yet they sum cleanly. The beauty of this method lies in its passivity. Nothing must ignite, nothing must be aimed. The star is the only switch. Torque is both hazard and gift. Jets that are not symmetric will twist the body. If the moments are large and irregular, the spin state can wander and risk structural failure. If the moments are small and planned, they can spin the object to a comfortable period, then maintain that period against outside influences. Pairs of vents placed at equal latitudes on opposite longitudes cancel most torques while leaving a net force. Triplets placed in triangular symmetry can supply trim control. A rotating frame can even be used as a mixer, distributing heat between vents over a day and preventing any one area from dominating. Engineers call this desaturation when applied to reaction wheels. Here it is performed by the ice itself, a slow dance between sunlight, rotation, and vapor. Dust complicates the story but offers leverage. Grains entrained in the flow add mass to the exhaust at the cost of lowering the mean speed. That reduces specific impulse, but increases thrust for the same number of escaping molecules. If the goal is to maximize acceleration while accepting faster mass loss, a dust-rich vent accomplishes it. If the goal is to stretch the supply while keeping the plume quiet, a cleaner flow is preferred. The balance can be self-regulating if grains are locked under crusts that open only at certain pressures. It can also be planned by placing vents in terrains with different cohesion, letting some regions feed grit and others feed gas. The combined thrust then smoothed by design. Navigation does not require a map if it uses the sun as compass. A traveller can keep a face aimed slightly off subsolar to bias the total push in a constant inertial direction. Over weeks, that constant push becomes a measurable drift from pure Keplerian motion. A slow inward ramp in thrust as distance shrinks mimics the way natural sublimation strengthens, so the drift remains camouflaged. If the body needs to change plane by a hair, vents near the poles can be favoured for a season. If it needs to speed up outbound to meet a rendezvous in the dark, mid-latitude vents on the evening side can take a larger share. The plan writes itself into the daily cycle, a metronome that space will happily keep. One may ask how such control could survive variability in solar weather. The answer lies again in patience. The response times of porous ice, clathrate layers, and thin crusts are long compared to minute-scale fluctuations in irradiance. Sudden changes in ultraviolet flux are averaged out by heat capacity and by the time required for molecules to migrate through the matrix. The throttle remains slow and graceful. When a coronal mass ejection blows through, plasma effects can charge grains and influence their escape, but the gas that carries them still obeys ordinary thermodynamics. The engine of ice is stubbornly conservative, which is exactly what cautious travel demands. Power is plentiful but dilute. The solar constant at Earth supplies about 1.5 kilowatts per square meter, less at larger distances, more when closer. A surface with modest absorptivity can turn a fair fraction of that into sublimation enthalpy. Water requires roughly 2.5 million joules per kilogram to move from solid to gas. Carbon dioxide needs less. With square kilometers of available area on even a small nucleus, the total energy budget supports thrust in the range we already sketched. Constraints emerge from geometry rather than from source. The art lies in presenting active area without sacrificing structural integrity, and in keeping vent throats unclogged without triggering catastrophic erosion. There is a complementary sail available to any bright body, the pressure of light itself. Photons arriving from the star carry momentum. Reflective patches can harvest that momentum and add to the slow push from gas. A traveller that places high albedo panels near regions of gas production can align the two vectors, light pressure and sublimation thrust, summing rather than fighting. Fine control becomes possible at almost no extra cost, since light works wherever gas works. The pair resembles a sailor who sets both canvas and engine to pull on the same line, then trims with a fingertip. In interstellar night, the engine sleeps, yet even then a trickle can persist. Radioisotope decay or stored chemical heat can keep a few vents breathing so lightly that frost simply migrates rather than vanishes. The result is self-repair. Open pores narrow, overactive throats glaze, quiet ones reopen as hoarfrost shifts under infinitesimal gradients. Time becomes the maintenance crew. When the star rises again, the network wakes in a configuration not too different from the one that survived the last crossing. What finally emerges is a portrait of propulsion that is humble and durable. It wastes nothing, it announces nothing, and it requires only the conditions that deep space provides in abundance. No valves need cryogenic sealants. No tanks need burst disks. The vacuum is the chamber, the sun is the heater, the ice is both fuel and structure. For a traveller that values discretion, the engine of ice is not a romantic choice, it is a rational one. It trades speed for anonymity, drama for longevity, and certainty for the soft power of many small decisions made correctly for a very long time. Imagine a vessel that treats cold not as an enemy, but as architecture. Its hull is not metal. Its walls are ice made intelligent by void and time. Within that frozen body lies an arrangement of spaces that behave like organs, each tuned to a different duty. The exterior is an ablative mantle that accepts sunlight and dust. Beneath, layers grow cleaner and stronger, guarded by porosity that redistributes stress. Deeper still, cavities hold what matters. The whole is a cathedral of low temperature, designed so that physics does most of the work while intention simply nudges. The skin begins as crust. Under irradiation, water-rich surfaces sinter into a tough rind a few centimeters to meters thick. Micrometeoroids shatter grains, but the fragments fuse at contact points, forming a foam that resists further erosion. Embedded sulfides and organics darken the albedo just enough to absorb a controlled fraction of sunlight. The purpose is counterintuitive and precise. A little heat encourages a slow bleed of gas that builds an insulating coma. Too much heat would tear the shell. Thermoelastic relief cracks are guided by predetermined weak seams that behave like expansion joints in pavements. When a seam opens, vapor vents along a path chosen long before, and torques distribute themselves in patterns that do not threaten the core. Just behind the rind, the ice is neither homogeneous nor random. It is a lattice of cored honeycomb, a field of cells connected by narrow throats. Each cell contains a mixture of crystalline and amorphous phases, with clathrate pockets that imprison volatiles until thresholds are crossed. The geometry turns phase change into control. As sunlight raises temperature by a degree here or there, only select cages release their cargo. Pressure rises locally, channeled through micro-nozzles that face chosen directions. The flow exerts gentle force while cooling the very structure that enables it. If fatigue accumulates, annealing can occur at tens of Kelvin below ordinary melting through slow molecular rearrangements, healing microfractures over months. Radiation protection comes not from heavy plating but from thickness and cleverness. Galactic cosmic rays penetrate meters. Solar energetic particles are shallower but intense. To minimize damage, high-density inclusions are scattered through the lattice as sacrificial targets. Iron-bearing grains and hydrated silicates absorb cascades and dissipate secondary electrons before they reach sanctum zones. Voids that lie along cosmic ray trajectories act as breakwaters, forcing showers to expand and lose energy in low-density volumes rather than in living chambers. Over centuries, sputtering erodes surfaces a molecule at a time, yet the honeycomb closes, ranks as vapor migrates and refreezes. The shape shifts without losing identity, like a glacier that remembers what it was carved to protect. The sanctum lies at the heart, a cluster of pressure-stabilized capsules that treat water not only as shield, but as medium. Isochoric thermodynamics becomes the key. Liquid sealed at constant volume can be cooled below freezing without forming destructive crystals, as pressure rises to maintain volume. Within such chambers, biological structures or delicate polymeric memories can remain intact at temperatures that preclude chemistry. Glass transition is the target rather than ice formation. Cryoprotectants derived from simple molecules like glycerol or formamide can be added in tiny quantities, chosen for stability against cosmic activation. The surrounding ice maintains near constant pressure by flexing, while slow heat leaks are met by phase change buffers that absorb joules without raising temperature. Information not tied to biology requires different faithfulness. Memory media could be crystalline stacks patterned at nanoscale, immune to bit flips by redundancy rather than by perfection. Multiple encodings sit in concentric shells, each shell separated by a vacuum gap that decouples shocks. Decoders are literal. They include etched instructions for any mind with spectroscopy and arithmetic, using universal features like atomic lines and simple geometry to bootstrap understanding. Power for a reader is stored not as chemistry, but as temperature gradients. Thermoelectric junctions of doped ice and embedded semiconductors produce trickles of current whenever sunlight touches the outer shells. The act of waking the object supplies the energy needed to read it, and reading it teaches how to keep it cold again. Structural logic prefers spheres and gentle curves. Sharp corners concentrate stress and invite cracks that race. Vaulting serves two masters, strength and conduction. Arches of denser ice carry loads around cavities while also acting as thermal bridges that can be turned on or off. Low conductivity routes are composed of aerogel-like voided zones where photons scatter and phonons stumble. By choosing paths with different mean free lengths for heat, the interior maintains pockets at staggered temperatures. A stratigraphy, not of rock layers but of entropy. Fragile cargo picks its stratum and rarely needs to move. Dynamics matters as much as static design. Rotation keeps illumination cycling, and cycling prevents any single sector from wandering into dangerous equilibrium. The period is not an accident. It is set by the interplay between distributed jets and the moment of inertia of a figure shaped to be lazy about changing its spin. Mass is concentrated outward in a subtle rim that raises the rotational inertia and resists perturbation. Cavities are placed in phase with each other so that seasonal heating produces matched responses, cancelling undesired torques. If a collision occurs, the honeycomb partially collapses around the wound, redistributing load and sealing fractures with refrozen exhalations. Materials can be ordinary and still act extraordinary. Water dominates, yes, but ammonia hydrates lower freezing points and seed vitrification at lower pressures. Carbon dioxide ices fill sacrificial stores that serve as early-stage coolant and thrust. Modest sulfates and chlorides provide ionic strength that stabilizes structures near triple points. Trace amounts of methane and methanol alter sintering and grain growth kinetics, slowing coarsening that would otherwise degrade mechanical properties. Nothing exotic is required. The magic lies in the ratios and in where those ratios are placed in 3 dimensions. Autonomy emerges from physics without microcontrollers. The crust brightens as it cleans itself through sublimation, then darkens as dust settles, forming a slow feedback loop that regulates heating. Vents clog with frost, then reopen when local pressure overshoots and clears throats. Frost lines migrate inward and outward with season, balancing mass loss against shielding gain. Even communication, if desired, can be passive. A reflective cavity can produce a narrow specular glint at a specific phase angle that recurs with rotation. A reader who maps brightness over many cycles could discover a simple code written in the timing of sparkles, a code that does not require transmitters or reveal itself when geometry is unfavorable. Logistics of manufacture raise questions that are surprisingly approachable. In a cold nursery of small bodies, a foundry could select a parent fragment with the right proportions and add structure by vapor deposition and sintering. Warmth is the difficult reagent in that environment, so assembly would favor low-temperature processes. Clathrates can be grown by exposing ice to gases at controlled pressures. Honeycomb cores can be machined by ablation with low power beams. Cavities can be inflated by sublimating trapped ices through patterned apertures. The work requires patience and an economy of force that any society with limited power would respect. Risk management rides on redundancy. No single chamber contains unique cargo. No single vent carries indispensable load. Communications by glint or by gravitational whisper can fail for seasons without consequence. Even failure itself is part of the plan. If the object loses integrity near a star, fragments still contain functioning microsanctums. Small pieces have higher surface area but lower absolute heating, and their coma contributions blend into a shared shield. A swarm can carry a mission across a gulf where single hulls would perish. Aesthetics are not the point, yet beauty arrives anyway. When interior vaults are modelled, lines of heat flow sketch shapes that resemble Gothic ribs. Stress maps reveal fan vaults where arches meet, coloured not by stained glass, but by gradients of Kelvin and Pascal. Snow at the microscale grows dendrites that echo trees under winter sky, pellicles that close pores glitter like frost on old windows. The hairline cracks that seem worrisome are instead sigils of resilience, proof that stress found the paths prepared for it, and did as it was told. Beyond the engineering, a philosophy is embedded. Cold is a currency, and time is the account it fills. The design asks for small sacrifices of mass to purchase decades of dark safety. It refuses speed that would shorten life, and it prefers maneuvers written into the bones rather than performed by loud machines. It does not invite discovery, nor does it fear it. If found, it is legible. If left alone, it is content to keep its temperature promises until the next star rises and gives it a reason to move again. Taken as a whole, the freezer ship is not a ship in the sense of decks and engines and bright consoles. It is an ecosystem of states, a city of thermodynamics carved into a single stone of ice. Its citizens are phases and pores. Its laws are conductivity, sublimation, and the soft authority of pressure that refuses to spike. In that city, the fragile lives at the center, safe not because someone watches constantly, but because the city was built so that watching is mostly unnecessary. That is what design can do when given a universe that already loves equilibrium. A message can travel without radios if the sender is patient. Gravity itself can carry syllables, and light can be made to stutter in ways that say more than brightness alone. An object that refuses to transmit in the ordinary sense is not voiceless. It speaks through the timing of its moves, through the choreography of its faintest forces, and through the metric left in a trail of photons that were merely passing by. Acceleration is the first alphabet. A point of light tracked against a field of stars yields positions that form a smooth curve when only gravity acts. Deviations from that smoothness are usually attributed to outgassing or radiation pressure. Those forces have predictable dependence on sunlight and geometry, so their signatures can be modelled. If the residuals after modelling contain a rhythm that nature does not commonly produce, the rhythm may be intentional. A sequence of micro-pushes could be spaced in intervals that form prime number gaps. Another sequence could echo the Fibonacci ratios that appear in many growth patterns yet are rare in orbital solutions. No antenna is required. Only a willingness to nudge by millimeters per second and to let weeks pass while watchers measure. Such nudges can be sculpted by subtle means. Microvents placed at chosen longitudes, warmed or shaded at chosen times, yield flutter that is tiny yet coherent. If the amplitude scales gently with distance in the same way that sublimation would, the pattern hides in plain sight. The trick is not in force, but in cadence. A code that repeats every few rotations, with small phase precession tied to the solar vector, creates sidebands in the timing spectrum that high-precision astrometry can hear. The shape of that spectrum can carry content the way the spacing of tree rings carries climate. Light offers a second alphabet through occultation. A coma is a living screen. When it passes in front of a dense star field, background points dim for moments as grains and gas absorb or scatter. If the density along the line of sight is modulated deliberately, the dips can be timed to form a pattern. Lines of slightly enhanced dust production released at specific rotational phases create curtains that sweep across stars like shutters. The observer sees a series of microeclipses that recur with a clock not tied to simple geometry. A sequence of equal spacings could signal counting. A sequence that grows by a constant factor could point to a base. All that is needed is a star field and patience to watch for dips measured in a few percent and lasting a heartbeat. Polarization supplies a third channel. Scattered sunlight is partially polarized, and the angle and degree carry information about grain shape and alignment. In a coma, turbulence usually randomizes those alignments. Brief order can be imposed by small electric fields set up across charged dust near vent mouths. A burst of alignment lasting seconds rotates the polarization vector by a few degrees at a chosen cadence. The effect is faint but measurable with sensitive polarimeters. A repeating ladder of polarization angles, ascending by equal steps and then resetting, becomes an unmistakable clock. A clock can carry meaning. It can announce the presence of intention without naming its source. Specular reflection offers a fourth path. Smooth cavities or thin reflective films can throw narrow glints when geometry allows. If the object spins with a stable period, glints recur in a sequence that can be tuned by tiny changes in attitude. A deliberate pattern might use pairs of glints separated by a fixed short interval followed by a long gap. The ratio of the short to the long is a number that can be chosen for significance. The short could be 1, the long could be 2, then 3, then 5. The watchers would record a cadence that refuses randomness. They would not need to know why it matters to know that it does. Gravitational messaging is slower and quieter, yet it can be the most durable. Mass ejected in tiny pellets alters the center of mass and the path by minute amounts. If pellets are released at a regular train that repeats after many rotations, the accumulated effect produces a sawtooth in the residuals of an orbit fit. A pellet train that encodes a binary string by changing spacing between releases stores that string in the trajectory forever. Anyone who reconstructs the path from careful astrometry will see kinks that are too tidy to be weather. The sky itself becomes the archive. Self-casting shadows add a different kind of control. Dust fans can be released on schedules that place thin sheets in the path between the sun and the nucleus, shading active terrain by small percentages for short periods. That shading changes gas production and thus the thrust vector. The resulting acceleration shifts encode a pulse that follows the schedule rather than the rotation period. The beauty of this method is that the same dust that sculpts the push also sculpts the optical signal. A paired signature appears, one in brightness and one in motion, each confirming the other. Chemical ratios can participate in messaging without revealing any new molecule. Fluorescence efficiencies in certain bands depend on the temperature of the gas and on the distribution of rotational states. Those states can be nudged by modest changes in outflow speed and local density near vents. If a sender alternates between two nearly identical thermodynamic regimes, the relative heights of neighboring spectral lines swap in a controlled way. A watcher with a high-resolution spectrograph sees a beat that is not tied to distance from the sunday. The beat can be made to represent a count. A count can be made to represent a simple idea, like a base for numerals or the period of a fundamental physical constant expressed in natural units. Coordinate systems themselves can be content. An object can choose a spin axis that precesses slowly to trace a circle of a chosen size on the celestial sphere. The circle's angular radius in arcseconds can be made to match a meaningful number such as a simple ratio of atomic masses. The period of precession can be chosen to be a small integer number of days. Neither choice is likely for debris. Together they produce a geometric figure a dynamical analyst cannot avoid noticing. Geometry becomes text. Instruments on Earth and in space would read these alphabets by different means. Wide-field images catch the occultations. Precision astrometry records the accelerations. Polarimeters hold angles steady while the signal accumulates. Spectrographs lean on stability rather than depth, letting line ratios tell the story. Each instrument demands calibration that removes its own inventions. Only after the inventions are gone can a rhythm be trusted. The rhythms that survive subtraction are stubborn. Stubborn is the quality that separates signal from the psychology of the witness. Ambiguity must be given its due. Natural processes can mimic many patterns, rotation couples to venting in ways that create quasi-periodicity. Dust tails can form striae that cross star fields at regular intervals. Polarization can flicker as viewing angles slide through regimes of scattering that are notoriously tricky. A responsible reading of any alleged message begins with all the boring explanations and remains within them as long as they are viable. Only when multiple channels agree does the hypothesis of intent deserve space. Agreement means that acceleration, brightness, polarization, and line ratios share a clock that is not set by the simple motion of a sunlit rock. There is also the ethics of listening. A sender that chooses gravity and shadow intends privacy by default. The message is legible only to those who work at the limits of measurement. Interpreters must avoid projecting their own hopes into a small dataset. The correct posture is patience in both directions. Patience to gather enough cycles for statistics, to be honest. Patience to leave questions unanswered when the cycles remain too few. Silence can be a word. It can be the first word in a grammar that says caution first, curiosity always, and disclosure only when both sides are ready. If a message is eventually recognized, it may not be a paragraph. It may be a single fact written in a slow code, perhaps a declaration of origin in a coordinate system based on pulsar timings, perhaps a table of prime gaps to prove arithmetic kinship, perhaps only a clock that keeps better time than ice should, the simplest test of agency. Elegant restraint is likely because the channel rewards simplicity. The universe is loud at every wavelength. It is quiet only in the regularity of motion. A craft that understands this will let motion carry meaning. In that view, the sky becomes a page, the sun a backlight, and the measuring instruments the eyes that read. The object at the center does not shout. It arranges. It adjusts by fractions. It relies on the fact that a civilization capable of noticing will also be capable of patience. The proof of attention is not a burst of radio. It is the gentle refusal to be random. Direction is biography written without letters. A body arrives from somewhere, and the somewhere persists in its velocity like a scent. To read that scent, astronomers change frames. They step out of Earth's swirl, out of the sun's ellipse, and into the quiet of the galactic frame, where motions sort themselves into three components, aligned with the Milky Way. In that frame, the old phrase, local standard of rest, becomes useful. It is the average flow of nearby stars, a kind of neighborhood wind. Peculiar motion is then the difference between an object's path and that wind. For a visitor from between suns, the peculiar motion is the clue that points toward history. Gaia star maps make such reading possible. Every year, the catalogue grows more precise, turning the sky into a kinetic sculpture with proper motions and radial velocities for millions of stars. With those vectors, a backtrace can be attempted. The idea is simple, even if the math is not. Integrate the orbits of the visitor and every viable nearby star backward through a model of the galaxy's gravitational potential. Mark near misses. Rank them by closeness and time. A very close pass at a plausible ejection time would be cause to look harder. No single path survives far into the past. Encounters with small masses and numerical uncertainties lead to divergence. Still, probability clouds take shape. They do not name a birthplace, but they exclude many. Patterns appear when many interstellar candidates are compared. Some arrive moving gently with respect to the local standard of rest, as if their story began in the Schlieren of gas that fills the local bubble. Others knife in with speeds nearer to the sun's natural drift through the disk. The first category suggests that ejection from another system happened so long ago that the object's velocity has been thermalized by countless encounters with diffuse mass. The second category suggests a more recent launch, tossed by a planet or a companion star without much time for frictionless blending. If a traveler wished to arrive without drawing attention to its speed, matching the local wind would be a kind choice. Galactic geography matters to peril and longevity. The sun sits inside a rarefied cavity carved by ancient supernovae. The density of dust and gas here is low. That means fewer collisions for a fragile hull and a smaller flux of cold atoms that would sputter surfaces and poison subtle mechanisms. The rims of the local bubble are busier and brighter in X-rays. A route that threads the quiet center is safer. The inbound vector of a cautious vehicle would favor this pale corridor over denser lanes farther from home. That choice would not be obvious to a natural fragment ejected blindly from a crowded nursery. It would be trivial to an engineer reading the interstellar weather. Spiral structure sets traps and offers gifts. The pattern speed of arms roughly matches the rotation of stars at a certain radius, creating the corrotation circle where stars linger with an arm for longer than elsewhere. On either side of that circle, Streaming motions appear as flows of a few kilometers per second relative to circular orbits. These flows effectively make rivers in the disk. Objects that share them are shepherded slowly along the same grand bends. It is tempting to imagine a species that charts these rivers and sails them the way ancient seafarers learned currents. In such a scheme, launch windows would not be dictated only by planetary alignments. They would also align to spiral weather, so that a crossing between arms is made in quiet water. Origin hypotheses grow more delicate when star clusters are involved. Open clusters dissolve on timescales shorter than 1 billion years, releasing stars into the field with similar velocities for a while after. Tracing back an interstellar object that shares a motion family with a known moving group could place its birth in one of those crowded nurseries. Natural ejection is quite efficient in such environments because close encounters are common, yet clusters that remain bound for tens of millions of years also host deep wells of shared memory. A people that had time to build slow ships might prefer to launch from such communities. The outbound path of a craft born under those conditions would carry the kinesthetic fingerprint of its siblings for a long time. Numbers give weight to this imagining. In the standard galactic coordinates U, V, and W, where U points inward toward the center, V follows the direction of rotation, and W rises toward the north galactic pole, measured peculiar speeds for interstellar wanderers tend to fall within a few tens of kilometers per second of the local standard. In practice, that means ejection speeds from parent systems were also within that range. An engineered vehicle would choose even smaller, peculiar speeds, because lower relative speed extends the lifetime of a delicate surface against dust, impacts by reducing both rate and lethality of collisions. It also stretches encounter times near stars, where sampling or braking by sublimation is planned. A vector with small u, small w, and modest negative v would be a signature of thrift. The plane of the galaxy is not a flat sheet of certainty. The disk oscillates. Stars bob above and below the midplane with periods near tens of millions of years. An object launched at a phase that minimizes time spent at high density near the midplane would see fewer molecular cloud encounters. Those clouds tug gently, but their drag on trajectory reconstruction is severe. Every pass near one smears the origin story. Choosing an epoch when the launch system and the destination region are both near their vertical turning points reduces complications. It also yields cooler radiation backgrounds, which matters to anything that prefers deep cold. If there is a source region hinted at by any inbound vector, it is the great archipelago of comet reservoirs around other stars. Analogues to our Oort cloud likely exist around many suns. When planets migrate or tides stir or passing stars pluck, those reservoirs scatter icy bodies outward. Most of those bodies proceed without curriculum. A few will be snared briefly by other stars, or will wander into the gravity well of a giant planet and be flung again. The net effect is a galactic haze of slow stones. The question is whether that haze alone can populate the number of visitors now being seen. If the answer demands more traffic than natural rates provide, then someone may be adding to the flow. Backtracing methods are honest about limits. Even with Gaia, uncertainties balloon backward in time. After a few million years, a volume of several cubic parsecs represents a candidate birthplace. That volume contains thousands of stars and ephemeral structures. Yet the shape of the probability cloud still conveys information. If it elongates along known streams in velocity space like the Hercules or Sirius branches, the path is almost certainly natural. If it hovers near the local standard with unusual precision, discipline might be suspected. Discipline does not prove intention. It does raise the bar for coincidence. Routes can be chosen for privacy. An inbound vector that approaches from the solar apex, the direction the sun is already moving toward, makes relative speed smallest. That reduces the glare of non-gravitational effects when the object breathes near the sunday. Inbound along the antipex would emphasize those effects. A cautious traveler aiming to minimize the chance that a young technosphere interprets thrust, as steering would prefer the apex. Statistical priors for random interstellar debris do not favor either direction strongly. Preference in a small sample carries little meaning. Preference maintained across many objects would be a sentence written in slow ink. Magnetic fields permeate the disk, but a neutral body with modest conductivity feels them only indirectly through the motion of charged dust and gas it carries. Engineers still care about those fields because they affect the behavior of any plasma sheath and can torque charged grains after release. The inbound vector relative to the large-scale spiral magnetic field influences whether dust wakes show certain striations. A decision to align so that striae look like familiar cometry features could hide oddities in plain sight. This is not fancy. It is simply prudence, disguised as naturalism. One may also consider the energy accounting of a grand tour. With no engines other than sunlight and vapor, a vehicle cannot change its galactic velocity by much. The course must be chosen at launch. That choice, if interpreted as a bequest from a distant intelligence to its future self, speaks of reliable maps that persist for millions of years. It implies knowledge of spiral rotation, of cloud motions, of the local bubble's evolution, and of the proper motions of target stars that will remain good for orders of magnitude longer than any human chart has held. To possess such maps is to inhabit a civilization that thinks in units of the galaxy's patience. Against this speculative architecture, the simplest reading always deserves first claim. A frozen stone tossed from a planetary hill can find its way into this system without help. Its inbound vector can mimic taste because the cosmos is rich in repetition. Yet science proceeds by demanding that residuals vanish. If the acceleration after modeling obeys only thermodynamics, if the brightness follows only solar distance, if the inbound vector aligns with ordinary streams within the expected scatter, then quiet reigns. If not, then the path in from the dark becomes evidence in itself. Galactic origins, then, are not just a matter of coordinates on a chart. They are a measure of the conversation between motion and time. A direction chosen long ago keeps choosing consequences now. Whether a traveller is born in a cloud or planned on a bench, the signature of that choice remains in the way it meets the neighbourhood wind. To study that signature is to learn not only where it came from, but how it thinks about distance. Material choice is an ethics as much as an engineering problem. A traveller that must cross light years without maintenance needs a propellant that doubles as shield, coolant, camouflage, and clock. Carbon dioxide satisfies each demand with a calm that feels intentional. It turns faint sunlight into control at temperatures where other volatiles sleep. It leaves signatures that are legible to specialists yet awkward for casual surveillance. It stores safely in architectures that a patient culture could build in ice without valves or wires. It is ordinary enough to blend and capable enough to steer. That combination is rare in a universe that punishes extravagance. Thermodynamics supplies the first argument. Sublimation temperature sets when thrust awakens. Carbon dioxide leaves solid for gas at conditions common in the outer system, far earlier than water would, and at pressures well suited to porous matrices that never see a true melt. The latent heat of sublimation is modest compared with water, which means the same watt of sunlight can move more molecules per second. That translates to thrust at large heliocentric distances where detection is difficult and heating is gentle. The vapor pressure curve is steep but not unruly, enabling a throttle linked directly to insulation. No heaters, no igniters, no tanks. Just geometry and the star. Cooling is the second argument. Sublimation consumes heat and carries it away with expanding gas. A nucleus that feeds on carbon dioxide thus stabilizes its own temperature without frantic outbursts. The gas also radiates efficiently in mid-infrared bands that lie in a part of the spectrum where a thin coma is transparent to its own light. Energy leaves rather than ricocheting back onto the surface. Mechanical stresses relax. Fractures propagate slowly if they propagate at all. In such an environment, fragile interior structures survive encounters with perihelion that would ruin a body cooled only by water's reluctant breath. Control forms the third argument. The difference between an impulse and a design is the timescale on which force can be modulated. Carbon dioxide permits small, steady pushes that map cleanly onto the day and the season. Arrange sub-centimeter vents throughout a honeycomb, and the gas will find throats without turbulence. Tune albedo and emissivity on patches a few degrees wide, and a bias in heat becomes a bias in thrust. Knudsen pumping through microchannels adds an undercurrent that persists even when vents glaze. The result is a vector that can be shaped without electronics, with a granularity fine enough to hide inside natural models of cometary activity. Storage is the fourth argument. Water's liquid phase is a hazard in vacuum structures. Carbon monoxide is difficult to retain in quantity without either deep cold or pressure shell. Carbon dioxide sits in a sweet band where clathrate cages and amorphous ice will hold it for aeons if temperature gradients are gentle. Grow those cages at low temperature in a nursery, then lock them under a sintered crust. They will surrender their cargo only when sunlight asks politely. This is not technology in the modern sense. It is horticulture in thermodynamic soil. A culture without metals could still tend such a crop. Stealth is the fifth argument, and it is not theatrical. Ground-based telescopes view through an atmosphere rich in carbon dioxide, which complicates direct detection of the molecule in incoming spectra. Observers infer its abundance indirectly via proxy, oxygen lines, or appeal to space telescopes that are scarce and oversubscribed. A traveller that chooses carbon dioxide as its main volatile therefore looks more ordinary than it would if it chose an exotic gas that lights up ground instruments. The same choice also mutes sodium and potassium outbursts because the thermal regime stays cool, avoiding the narrow, showy lines that attract attention. Camouflage by chemistry does not require deceit. It requires choosing the molecule that observers least enjoy measuring. Manufacturability is the sixth argument. Carbon dioxide is abundant in cold reservoirs and easy to harvest as frost, solid, or clathrate, without heavy machinery. Its chemistry is inert under most deep space conditions, so it does not spoil coatings, poison catalysts, or polymerize into problematic byproducts. In mixtures with water and simple organics, it alters sintering rates and porosity in ways that can be exploited to sculpt microstructures. A workshop that can carve and gently heat ice can produce vents, valves, and reservoirs from these mixtures, and watch them self-regulate as the geometry comes alive under light. The bill of materials stays inside the geology of small worlds. Compatibility builds the seventh argument. Dust entrainment in carbon dioxide flow differs from that in water. The colder gas carries fewer large grains, which keeps plumes clean and makes mass loss predictable. Clean plumes avoid torques that jolt a body into chaotic tumbling. They also reduce the optical depth close to the surface, preventing runaway shading that would starve vents in a feedback spiral. If dust is wanted for shielding or for optical misdirection, it can be added by opening vents in terrains with different cohesion. If dust is not wanted, the carbon dioxide regime helps keep it at bay. Control remains with the architecture, not with the random grip of grit. Detection ethics shape the eighth argument. A civilization that intends to be discreet might nevertheless wish to be readable to those who deserve to read. Carbon dioxide allows this dual posture. It hides from casual surveys, yet reveals itself graciously to narrowband instruments and space-based spectrometers. Anyone who invests in careful oxygen line photometry, in mid-infrared spectroscopy, in polarimetry that tracks grain behavior at low temperatures, receives clarity. Anyone who scans quickly in broadband colors sees a familiar comet. The material choice thereby enforces a selection on the audience. Only careful listeners hear the full story. Safety is the ninth argument. Carbon dioxide will not burn, detonate, or catalyze runaways in the presence of common cometary salts. It does not breed corrosives when irradiated the way some halogen-bearing ices can. Shock waves from small impacts damp quickly in porous matrices saturated with this gas. Outgassing through cracks tends to widen them slowly rather than shattering them, because pressures remain modest. A vessel whose life depends on never experiencing a catastrophic spike would prefer such manners. Clocks provide the 10th argument. Rotational and seasonal modulations of carbon dioxide flow are clean functions of illumination and geometry. That regularity can carry timing without devices. A code based on the ratio of day-night production, or on the spacing of small vents around a meridian, can survive millennia without repair. The molecule becomes a timekeeper because its physics is stable and its response to light is simple. In a world where electronics die and lubricants freeze, turning a material into a clock is a triumph. There are counter-arguments. Carbon monoxide offers higher exhaust velocity and deeper cold. Its volatility, however, makes storage harder and leaks more dangerous. Water is abundant and structurally strong in bulk, but it waits too long to help with early thrust. and it stresses interiors by insisting on higher temperatures for activity. Ammonia hydrates lower melting points and lubricate grain boundaries, yet their chemistry is messy under irradiation, and they advertise themselves in spectral regions that are easy to monitor from the ground. Against such competitors, carbon dioxide looks plain. Plain is often what survival needs. Isotopes add a final layer of intention. Slight enrichment in a heavier carbon or oxygen isotope would barely change detectability, but would subtly shift thermophysical properties. Sublimation rates, clathrate stability fields, and radiative efficiencies nudge by fractions. A designer could use those fractions to align behaviors across a wide temperature range, ensuring that the engine of ice remains linear rather than lurching. To a remote observer with exquisite instruments, the isotopic ratios would look odd, but not impossible. To the object itself, they would feel like comfort. If a traveller must be quiet, must steer with whispers, must cool itself as it acts, must be buildable in the deep without smelting or organics factories, and must be legible only to those who watch with care, carbon dioxide becomes less a choice and more a foregone conclusion. It is not a proclamation of sophistication. It is a declaration of priorities, longevity, patience, and the humility to let a molecule do the work that machines would shout about. The simplest possible thing that satisfies all constraints is often the wisest path through cold space. Silence can be a strategy, not a defect. In the deep arithmetic of survival, the quieter choice often dominates loudness, especially when distances stretch beyond intuition and consequences mature across centuries. The question that rises like mist from cold ground is simple to state and hard to dismiss. If a visitor is crafted, why would it refrain from speaking in any of the ways a young, alert species understands? 3 families of motive answer from different corners of the same dark forest: kindness, caution, and predation. Kindness wears the shape of restraint. A civilization that treats living worlds as sanctuaries might practice an ethic of non-interference. Watch but do not alter, learn but do not parade. Approach only in forms that biology reads as harmless weather. Culture can be fragile, as any anthropologist learns when a camera lens changes the ritual it records. Biospheres are more fragile still. Even a benign transmission can seed panic, cult, or false certainty. A gentle creed would insist on silence until the recipient demonstrates that curiosity will not crumple into worship and that skepticism will not collapse into fear. Under such a creed, a probe would be built to gather, archive, and leave, making itself a mirror rather than a trumpet. Communication would not be a right extracted from the sky. It would be a privilege earned by patience on both sides. Caution is sterner and more mathematical. A galaxy is not a commons with referees. It is a sparse arena where contact is rare, information is asymmetric, and time horizons dwarf the tenure of empires. In that arena, a strategist calculates that every act of broadcasting advertises a location to unknown listeners with unknown incentives. The expected risk of calling out can stay high even if the probability of a hostile listener is low, because the cost of being found by an adversary is ruin. Game theorists call this a risk-dominant equilibrium. The safest stable behavior for all players is to remain quiet, to learn passively, and to use signatures that blend into natural noise. A vehicle meant to serve under these rules would make itself a creature of ambient forces. It would rely on clocks written into sunlight and gravity. It would prefer to look like a local phenomenon and to leave no residue but the memory of its orbit. Predation is the motive that chills without baroque embroidery. Not a cartoon hunter lurking behind stars, but a patient opportunist that treats resources, information, and safe corridors as prizes to be acquired with minimal exposure. To such a mind, reconnaissance precedes any move worth naming. The purpose of a silent courier would be to map gradients, energy, matter, biosignatures, traffic density, radiation weather, the presence or absence of defenders. If the gradients are uninteresting, leave. If they are enticing, mark the map in ways that only a returning craft can read, perhaps with nudges that alter a trajectory by fractions, perhaps with dust that carries isotopic watermarks, perhaps with numbers left in the cadence of motion. Predation need not culminate in violence. It can culminate in exploitation that never announces itself, the way a parasite succeeds by leaving its host alive. To choose among these motives, one must look for tensions. Kindness avoids contamination, caution avoids detection, predation avoids cost. In practice, the design features that serve one often serve the others. A low-signature vehicle that refrains from active transmissions both respects a biosphere and lowers its risk profile. A machine that uses ambient forces for control both hides and economizes. This alignment makes inference treacherous. What looks like ethics can be budget. What looks like fear can be mercy taught by long experience. Cost alone almost explains the preference for quiet. A beacon is cheap, but it locks a civilization into a posture of permanent revelation. A fleet of persistent physical couriers is expensive, but each carries less existential risk. Between those extremes sits the lurker, a long-lived, self-repairing observer that spends most of its time asleep, wakes only when the geometry is kind, and relays its harvest not by shouting to the stars, but by leaving a trail for its own kin to follow. In the calculus of a species that thinks in units of millennia, upfront cost amortized over eons beats short-term savings multiplied by existential hazard. Risk is not only external, there is the risk of error. A false positive for intelligence on a young world could trigger premature contact that harms both sides. A careful protocol would demand repeated, independent confirmations across many indicators before any change in posture. Intelligence detection, under that protocol, would require seeing not merely radio but sustained, planet-scale thermodynamic anomalies, orbital modifications of moons or asteroids, global spectral signatures of engineered materials, and the unmistakable seasonal rhythms of industry. Only then would a messenger be permitted to speak. Until then, each pass would add a layer to a long dossier that travels with the courier or hides within it. The ethics of kindness can be stricter still. A non-interference code might treat the presence of a young technology as a reason to back away, not to lean in. The rationale is paradoxical yet coherent. Awareness of being watched can change the watched. Culture under observation may perform for the observer. A species that learned this lesson at home would design probes that present themselves to instruments as comets or minor asteroids, leave no debris that reads as artifact, and choose flight paths that minimize temptations to heroic interception. The goal is not merely to evade weapons, it is to deny a story that could derail self-discovery. The cautionary motive learns from statistics. Life may be common. Mature, durable intelligence may be rare. If so, most attempts at technology die out, leaving ruins and odd chemistry in their wake. Survivors of that sieve would optimize for error tolerance. They would favor architectures that fail gracefully and leave nothing legible to scavengers. A visitor built under such conservatism would not have a single point of betrayal, no obvious antenna, no reflective plaque, no distinctive spectral marker. If it must encode a message, the code would ride on dynamics so slowly that only a reader with long attention could hear it. The hope is that only peers possess such attention. Predation, examined soberly, can be rational without malice. A society that builds self-replicating industry may require continual supply of rare isotopes, complex organics, or low-entropy ice. Mining these from sterile reservoirs is safer than touching biotic worlds. A scout then searches for sterile abundance and avoids any place that sings with life. Silence in this model is camouflage for a conscientious thief. The hunter's patience appears not as a plan to strike a living world, but as a promise to leave it alone if it is loud enough. Ironically, the best defense for a young biosphere under this rule is not hiding. It is singing clearly that it is alive, so the careful raider moves on. These motives intersect with a final, more intimate motive: curiosity protected from self-harm. A powerful culture might fear the mythologies it could trigger. It might also fear the diseases and ideas it could import. Even a machine can carry microbes in crevices or code in memory that becomes contagious if translated. The safest way to learn about others is then to use vehicles that visit briefly, expose no living wetware, share no software, and refrain from exchanges that compel reciprocity. In this light, silence is not indifference, it is inoculation. Counterarguments must have their day. Silence can be accidental. The traveller could be a relic without current stewardship, acting out instructions written for different targets. It could be a natural stone misread by minds eager for narrative. It could be a convoy component that carries no channel at all. Philosophy bends to evidence. Yet philosophy also prepares the questions that evidence should be asked. If absence of obvious communication is expected under multiple rational motives, then silence does not weigh against the artifact hypothesis as heavily as instinct suggests. The right test is not whether it speaks the way novices hope. The right test is whether its quiet is the particular quiet that plans make. How would that particular quiet reveal itself? Through choices that minimize couplings to alien systems, through paths that avoid corridors of interest to indigenous traffic, through materials that resist curiosity, not with violence, but with ordinary spectra, through data practices that leave behind only what the builders are willing to have read by strangers, through a patience that treats decades as a single, unbroken gaze. The dark forest is not a place of horror in this reading. It is a place where wisdom knows that light carries far and that eyes are everywhere. Walking softly there is not cowardice. It is civilization remembering that it once walked loudly and learned better. If a crafted traveller passes without raising its voice, the silence may be the oldest courtesy in the galaxy, or the oldest precaution, or the oldest tactic of extraction that does not scar what it takes from. The sky does not label which. It leaves the label for readers to infer, slowly, with instruments that respect the cost of being wrong. A strange idea earns survival only by facing tripwires, not by collecting admirers. The experiment is simple to name and hard to do. Specify behaviors that natural objects almost always display. Specify alternative behaviors that would be improbable without planning. Then watch, measure, compare, and let the ledger of probabilities speak in a voice no myth can imitate. Dynamics is the first tripwire. Fit the path with pure gravity and record the residuals. Then add a standard outgassing model with activity that scales as a power of solar distance and rotates with a single period. Compare with a thermophysical model that allows a handful of discrete vents on a rough surface. Finally, permit a non-zero acceleration normal to the orbital plane and ask whether it remains steady in sign across many weeks. Planets and random cliffs do not keep a plane with that kind of loyalty. If the normal term refuses to wander, if the transverse term scales with distance as if following a script rather than terrain, the curve has stepped on wire number 1. Precision matters more than poetry in this arena. Astrometry must be tied to the best star catalogues, with colour terms and field distortions removed, and with timing logs that have been audited as if they were bank ledgers. Multi-station observations close in time remove parallax confusion. Recovery frames extend the baseline backward, hardening the fit. Only then do residuals earn interpretation. Once the arithmetic is clean, perform a Bayesian model comparison between natural templates and a small library of control laws that reflect patient steering with vapor. If the odds lean toward control, the result is not a verdict, but it is a refused dismissal. Rhythm is the second tripwire. Light curves are stories about rotation, vents, and viewing angle, told in magnitudes rather than words. Run periodograms, but do not stop there. Use wavelets to test for clocks that drift slowly, and for patterns that recur at ratios unlikely under simple tumbling. Compute the information rate of the brightness sequence using symbolization and entropy estimates. Natural jets often produce quasi-periodicity with broad peaks. Intention prefers narrow lines and ratios that stay put. A ladder of intervals that approximates primes, or a repeating pair of incommensurate frequencies, whose ratio remains constant while the amplitude changes with distance, would be a signature with few plausible geologies. Spectra lay a third wire across the path. Monitor line ratios in CN, OH, C2, CO, and CO2 at high resolution and high cadence. Extract rotational temperatures from band shapes. Map how those temperatures change with phase angle and time of day on the nucleus. Natural flows wander with illumination and with topography. Intentional modulation would present toggles that recur at precise rotational phases regardless of distance, as if a switch were being thrown. Cross-correlate those toggles with the small accelerations inferred from dynamics. Agreement between chemical toggles and micro-pushes raises the probability that one clock rules both. Polarization forms a fourth test. Measure the degree and angle of linear polarization as functions of phase angle in several wavelength bands. Many comets follow a well-known curve, with a negative branch at small angles and a broad positive maximum near right-angle scattering. Anomalies exist, yet they usually track with dust-size distributions that evolve as heating proceeds. A staircase of polarization angles that steps through a repeating set of values, or a curve that remains unusually tight in spite of distance changes and outbursts, would hint at aligned grains being commanded into order on a timetable. Calibrate ruthlessly, because instruments invent polarization when mirrors age and optics are dusty. Thermal behavior is a fifth test. Read in mid-infrared, where grains and surfaces glow with their own heat. Build a thermophysical model that includes rotation, thermal inertia, roughness, and self-heating. Fit the color temperature across phase angles and distances. Many small bodies require patchy emissivity, high roughness, or peculiar beaming parameters to match the data. That is acceptable. What would be difficult to explain away is a constant color temperature during phases when models predict a rise or fall, or a repeatable kink at the same local time, as if a louver had opened and closed. Dust microphysics supplies a sixth tripwire. Derive size distributions from the slope of the scattered light and from thermal emission, ideally with simultaneous observations. Track the slope over time. Nature tends to broaden distributions as grains, fragment, and sinter, and to shift the mean size with changing radiation pressure and drag. If the distribution remains narrow and centered in a regime that suppresses spectral features and flattens polarization, the cloak begins to look tailored. In that case, search for departures only during geometry that hides them best, because camouflage designed for a particular viewing angle will relax at others. Occultation and scintillation tests add a seventh layer. As the coma drifts across star fields, record micro dips in background starlight at high cadence. Build a map of column density fluctuations as a function of time and rotational phase. Natural turbulence and fragmentation create a noisy spectrum, a pattern that repeats, with curtains of dust passing on a schedule that maintains equal spacings to within strict tolerances, is unlikely to be weather. Radio scintillation of background sources can be treated the same way, turning the plasma sheath into a diagnostic of artificial regularity. Geometry against observers is the eighth wire. Compute the distribution of solar elongations and ecliptic latitudes during the weeks of maximum scientific interest. Compare with the distribution expected for a random interstellar orbit chosen from the observed population. A path that systematically inhabits the glare near dawn and dusk, or that hides inside low-latitude strips where survey cadence is weakest, deserves a raised eyebrow. One event tells little. A sequence of such events across objects would speak of someone who knows the search patterns of a young technosphere. Tripwire 9 is coherence across channels. Align all clocks in a single analysis, linking the phase of accelerations with the phase of spectral toggles, with the phase of polarization steps, with the phase of micro-occultations. When multiple channels carry the same beat while responding differently to changing distance, the joint likelihood under natural models drops sharply. Assign p-values only after correcting for the many ways a pattern can be found by accident, and insist on independent teams repeating the analysis with different pipelines and with pre-registered metrics to avoid opportunistic tuning. Tripwire 10 is an offered null. Publish, early and clearly, a set of conditions that would count against the artifact hypothesis. For example, a significant and chaotic change in spin state that tracks a specific outburst, or a dust size distribution that broadens and shifts exactly as thermal fatigue models predict, or isotopic ratios that sit comfortably inside the widespread already catalogued in solar system comets. Make the rules before the results are in. Bind the narrative to falsifiable claims. The story survives scrutiny only if it invites its own defeat. Tripwire 11 considers unusual materials without assuming science fiction. Search for mid-infrared features from crystalline silicates that would imply thermal histories inconsistent with long-term deep cold, or for narrow absorption edges from organics that require recent processing. Look for centimeter radar echoes that are surprisingly bright and specular, as if smooth voids or plates hide inside, yet appear only at certain aspects. If such hints are found, they must repeat across nights and geometries before meaning is assigned. Tripwire 12 is ethical, yet it is part of the method. Decide in advance which active probes are acceptable. A powerful radar ping can reveal structure, but it also advertises the pinging civilization to a larger audience. A laser light curve experiment can test for specular cavities, but it could also deposit energy in a place designed to remain cold. The threshold for active test should rise with the plausibility that consciousness or delicate cargo is present. Caution protects both sides of the equation. Statistical hygiene wraps all of this like a clean room. Share raw data and code. Blind analysts to key epochs when possible, so that tuning cannot follow a desired outcome. Split the time series between teams and compare conclusions before merging. Encourage null results to be written with as much care as positive claims. An elegant hypothesis that fails an honest test gains dignity by failing on the record. If the wires remain untripped, the hypothesis returns to the shelf without shame, or needs no artifact to justify itself. If one or two wires snap underfoot while others stay intact, curiosity merits more time. If many sing at once, the burden of proof begins to shift. The next round of questions would not be louder, only narrower. They would ask whether the pattern persists on the outbound leg, whether similar patterns appear in other visitors, whether a quiet code transits from possibility to persuasion. In the end, testing is a craft for people who believe that reality rewards humility. The work is tedious, the metrics unforgiving, the temptations to dramatize resisted by habit rather than heroism. That is the point. A claim about intention written into the path of a distant traveler should face standards that would break most stories and leave only the ones that do not need help standing. If an object is merely stone and ice, the tripwires will stay untripped. If it is more, the wires are already waiting, stretched across the night by those who think wonder is valuable precisely because it dares to be measured. Eyes multiply when a rare traveler appears. Telescopes in deserts and on volcanoes open shutters in concert, while spacecraft already awake in the cold adjust their gaze by fractions of a degree. The planet behaves like a nervous system, passing impulses along fiber and radio until a global rhythm forms. Wide fields sweep for motion, narrow fields linger for detail, infrared follows heat, ultraviolet traces fragile chemistry, radio listens for grains and plasma murmurs. The choreography is neither accidental nor rigid. It is the learned grace of instruments that have practiced together through meteor showers, occultations, and supernovae, now tuned for a single faint point that will not return. A survey camera begins the cadence. Its detectors paint the sky in tiles with exposure times short enough to catch motion without smearing stars into scratches. Difference images subtract yesterday from tonight, leaving a crisp residue wherever something moved. Algorithms rank candidates and whisper coordinates to a clearinghouse watched by observatories from New Mexico to Namibia. The message is simple and urgent. New ephemerides, new uncertainty ellipses. Act now. Within minutes, medium aperture telescopes switch to non-sidereal tracking so that the object stays pinned while the stars drift. Photometry starts, a steady metronome of brightness measurements that will later become rotation periods, activity curves, and clues about surface roughness. Spectrographs cue next. A slit crosses the faint coma so that the white of sunlight can be split into lines that carry identity. Observers choose gratings according to distance from the sun and phase angle, trading resolution for signal in a way that keeps secrets at bay without wasting photons. Calibration lamps fire. Skylines are mapped. The instrument's own breath is removed, so that only the visitor's breath remains. Data flow across networks into reduction pipelines that have learned how to treat cosmic rays as lies and scattered light as flattery not to be trusted. Line lists wake on disk and begin to search. Every molecule that glows in vacuum has a favorite wavelength. The list remembers them all. Adaptive optics claim the hours of good seeing. Mirrors flex hundreds of times per second to cancel the atmosphere's shake, letting near diffraction-limited images reveal the inner tens of kilometers of the coma. If jets exist, even gentle ones, the high contrast frames will tease out their directions. If the nucleus is elongated and tumbles, a subtle elongation in the point spread function may betray it. Polarimeters share the same nights, rotating analyzers with a patience that borders on devotion. Grain sizes and shapes reveal themselves in the angle and degree of polarization. A picture builds from redundancies. Brightness tells only part of the truth. Angle tells the rest. Spacecraft fill in the gaps that ground cannot touch. Solar observatories with coronagraphs nibble at the glare, cutting a black disk out of the sun so that faint visitors nearby can be tracked when dawn on Earth defeats the night. Infrared telescopes outside the atmosphere measure color temperatures without the interference of water vapor and clouds, reducing guesswork about thermal inertia and emissivity. Time allocation committees that normally demand months of notice open quiet doors labeled target of opportunity, because the sky sometimes hands out problems that refuse to wait. Instruments built for galaxies bend for a moment to a stone with a halo. Radio arrays add a different sense. At millimeter wavelengths, rotational lines of carbon monoxide and carbon dioxide can be mapped into velocity fields that reveal outflow speeds and asymmetries. With luck, a line profile tilts just enough to suggest which hemisphere breathes harder. At centimeter wavelengths, the scintillation of distant quasars behind the coma can be measured, turning fluctuations into a map of electrons and microturbulence. Radar might try a ping if geometry cooperates, but distance usually defeats such ambition. Even silence at these wavelengths becomes a datum, constraining density and grain size where light is blind. Coordination is an art of clocks. Ephemerides update hourly as new astrometry arrives from small domes under stubborn skies. Observers in Chile plan around dawn, hand the object to Hawaii, which hands it to the Canary Islands, which passes it to South Africa and Australia. Gaps shrink until the light curve becomes continuous across nights and oceans. A collaborative document grows, time-stamped and versioned. Observers record filter sets, exposure times, air masses, and seeing. Reduction teams post 0 points, color terms, and warning notes about cirrus or dust that could tilt a slope by a percent. The instrument makers watch too, advising on quirks that only those who built the devices remember. Data quality is guarded like a ritual. Frames are bias subtracted, flat-fielded, and cleaned of cosmetic defects. Cosmic rays are clipped by algorithms tuned to remain merciful with faint trails. Apertures for photometry are chosen to match the seeing so that coma flux does not drown small changes. Reference stars are vetted against Gaia catalogues for stability and color proximity, because mismatched colors breed spurious trends. Every step is written, because reproducibility is the only defense against stories that want to be true. Prediction enters as a creative act bounded by equations. Finite element thermophysical models simulate a rotating body with roughness, albedo patches, and vents. Synthetic light curves are generated under the actual observing geometry. Teams try to make the synthetic curves misbehave in the same way the real ones do. Success earns suspicion rather than celebration. If ordinary physics can impersonate the observed rhythm, the case for design weakens. If not, the parameter space is tightened, and telescopes are pointed to geometries where models disagree most loudly. Observers then chase the disagreement, because that is where clarity lives. Occultation campaigns become moon landings in miniature. The predicted shadow of the coma across a star is mapped onto Earth's surface minutes before the event. Amateurs and professionals scatter along roads with portable setups, each stationed to catch a dip that may last a second. Success nets silhouette constraints of astonishing precision, far beyond what imaging could do. Even a failure teaches, because timing and non-detections refine the coma's density profile. After the event, dozens of clips are stitched into a single curve that reads like a seismograph of the cloud. Ethics steer certain choices. High-power lasers could probe microglints, but the risk of heating sensitive structures argues against it. Powerful radars could paint shape, but broadcasting reveals the broadcaster beyond the planet. Teams weigh curiosity against prudence and lean toward instruments that take without touching. The policy hardens into precedent, that will be remembered when the next rarity arrives. Science proceeds, but not at any cost. Machine learning plays a role, carefully leashed. Neural networks trained on years of comet observations flag frames where jets appear. Another network classifies polarization curves by shape and alerts when a pattern deviates from families already known. These models are kept honest by cross-checks against physical codes. They are servants, not oracles. Whenever a network points to anomaly, a human asks whether calibration changed, whether air mass grew, whether the moon rose behind thin cloud. Only after the boring explanations fail does the alert graduate to interesting. The final product is not a single paper or image. It is a mosaic of light and time that can be revisited. Raw frames live in archives with persistent identifiers. Reduction scripts are published with hashes so that their lineage cannot be counterfeited. Spectra are bundled with line lists, sky models, and masks that show what was ignored. Radio data arrive with beam patterns and system temperatures. Even the null observations are cherished, because they close doors that speculation would otherwise wander through. What emerges from this fleet is not certainty on demand. It is discipline that narrows possibilities without crushing wonder. The planet's eyes do not agree on every detail, but they agree on how to disagree. That is the quiet victory. A rare point of light passes through the shared field of view, and the species that built glass and code proves able to watch without panicking, to infer without inventing, and to remember without distorting. The nervous system fires, then rests. The next night, the shutters open again. Photons arrive as witnesses. Some have touched dust and changed direction. Some have rattled through molecules and emerged as lines. Some have simply counted the rhythm of brightness without asking what made it. Taken together, they behave like interrogators, who know how to listen more than they speak. Grain sizes, spin states, and gas flows confess in their voices. The work is to translate without rushing the truth. Dust speaks first in the way it scatters. The brightness at a given phase angle follows a curve that can be compared with families of models built from spheres, pebbles, and fractal fluff. Me-theory draws the simplest family, elegant but often too neat for real grains. Distributions of hollow spheres and T-matrix solutions for rough aggregates get closer to the world that Frost builds. If the phase function is unusually tight, peaking more sharply than expected and holding its shape as distance changes, the grains may share a narrow size band. Natural fragmentation tends to broaden that band as heat cycles nibble at clumps. An engineered sieve would keep it narrow, because a narrow band stabilizes polarization and flattens spectral color. A coma that holds to such discipline while geometry changes begins to look curated rather than eroded. Color amplifies or softens that impression. In reflected light, many primitive comae redden with increasing phase angle, a behavior called phase reddening that follows the physics of rough surfaces and multiple scattering. If the color slope refuses to redden, or reddens to the same degree night after night despite different lines of sight, the grains are behaving as though their microstructure is not evolving. Thermal emission in the mid-infrared adds a second lens. Grain temperatures inferred from color often exceed equilibrium when very small particles dominate. If the color temperature remains pinned near equilibrium, while the scattered light implies fine grains, a contradiction appears. The contradiction dissolves if hollow grains are used, or if coatings are tuned to balance emission and scatter, both of which can be made by patient sublimation acting on purpose. Polarization is dust telling a more intimate story. The degree and angle of linear polarization across phase angle draw a characteristic curve that includes a shallow negative branch at small angles and a broad positive hill near right-angle scattering. The Umhof effect links darker surfaces to higher polarization. Deviations are common, yet they wander with heating and activity. If a coma draws nearly the same polarization curve across many days, if its negative branch is unusually suppressed, if its angle steps through a small set of preferred values as though grains align briefly and often, the claim of ordinary turbulence weakens. Weak electric fields near vents can align non-spherical grains for seconds. Repetition at a constant cadence would turn such alignment into a metronome that no weather forecast expects. Gas lines testify about sources. The violet CN band near 388 nanometers, the OH band near 308, the green forbidden oxygen at 557.7, the red doublet at 630.0 and 636.4, the swan bands of C2, and the rotational ladders of CO and CO2 the infrared, are the usual witnesses. With fluorescence G factors and vectorial or Hazer models, production rates can be pulled out of line strengths. Rotational temperatures, extracted from band shapes, tell how the gas was born and how it cooled. Natural flows make those temperatures drift with distance and with local time. A toggling between two states that repeats at the same rotational phase regardless of distance would be a more deliberate tempo, like a shutter opening and closing on a clock, rather than a surface catching and releasing heat. Ratios reveal intent more than absolute strengths. The OI 557.7 to 630.0 ratio is a proxy for the split between water and carbon dioxide sources, modulated by quenching and gas density. A ratio that glides gently with heliocentric distance looks like chemistry breathing. A ratio that holds a plateau too long, or that oscillates with a period unlinked to illumination, hints at a controller that refuses spikes and prefers flats. The ortho to para ratio in water, often treated as a fossil thermometer of formation, drifts only with strong processing. If it were found to change subtly on a schedule, the conclusion would be either exotic physics or intentional cycling of temperatures deep inside. The second option demands restraint before it is allowed, yet it would account for coordinated behaviors across dust and gas in a way that one missing ingredient rarely does. Light curves do not care about composition. They measure brightness as time and turn the sequence into clocks. Lomskagel periodograms find dominant periods, wavelets find drifts, autocorrelation maps find nested rhythms that can be missed by eyes that expect tidy sinusoids. A single, stable rotation period is unsurprising in a well-behaved nucleus. Two incommensurate frequencies can signal non-principal axis spin, a tumbling that natural torques often provoke. If instead a sharp fundamental is accompanied by sidebands that remain at fixed offsets across weeks, a modulated thrust could be painting the curve. The amplitude phase relation tells whether changing viewing geometry or changing vent strength drives the light. A plateau where a peak should rise, night after night, marks either a coma that thickens precisely when needed or a set of active regions paired to cancel shadows. Both can be arranged by terrain. Both can also be arranged by design. Correlations across channels give the strongest leverage. A modest increase in polarization degree at a certain rotational phase should coincide with a subtle change in CN or OH line ratios if grain alignment and volatile release are being managed by the same heat pulse. A tiny acceleration normal to the orbit plane should line up with a thermal color change if a vent that supplies that push also cools a face. Cross-wavelet coherence tools quantify such alignments and grade them against what random coupling would produce. Randomness does create coincidences. Coherence that persists while the viewing geometry evolves deserves a harder stare. Syndynes and synchrones, the maps of dust sorted by size and by release time, let tails store clocks. The patterns in a wide-angle image unfold as threads that can be traced back to emission epochs. If those threads recur in equal spacings, a scheduler may be at work. Conversely, if the threads fan out with the expected one over beta geometry, where beta marks radiation pressure, ordinary radiation physics remains king. Deviations near the nucleus are easy to forge by seeing and glare. Farther out, in calm air and deep dark, the geometry grows honest. Honesty out there confirms or rejects hints seen close in. Models convert testimony into sentences. A thermophysical code with realistic roughness and porosity can produce light curves that mimic many quirks. A jet model, coupled to a convex shape, can mimic non-gravitational pushes that look purposeful. The discipline is to let those models fail as often as they succeed, then to ask whether the same small set of parameters explains many independent datasets. If one distribution of grain sizes, one arrangement of vents, and one thermal inertia explain polarization, spectra, light curves, and astrometric residuals without changing their values when the geometry changes, either the object is exceptionally regular or someone liked regularity enough to build it in. Systematics deserve suspicion before any romance is allowed. Polarimeters invent degrees if mirrors age. Spectrographs drift when temperature control stumbles. Photometry can be fooled by air mass if color terms are not honored. Teams that split data blind, swap reduction scripts, and publish calibration frames, along with results, inoculate themselves against their own hopes. Only after those inoculations take hold do the patterns that remain become candidates for meaning. Some signatures would be particularly heavy. A dust-size distribution that stays log-normal with the same narrow width for weeks argues selection, because natural grinders broaden it. A polarization curve whose negative branch is suppressed to almost nothing, while the positive maximum sits with machine-like repeatability, suggests aligned grains on command. A set of gas line ratios that toggles between two plateaus with phase-locked timing indicates thermal regimes being chosen, not inherited. A light curve whose side bands encode intervals in ratios that prime numbers prefer is a code until proven otherwise. None of these are easy to claim. That difficulty is the point. In the end, the photons that left the visitor carry a ledger of its habits. They do not accuse. They do not exonerate. They return as sworn affidavits that must be read with humility. If dust broadens, lines wander, and light curves drift with the weather of a small, sun-warmed body, the verdict is simplicity. If the curves refuse to wander, and the clocks keep too good a time, intention steps forward as a hypothesis that has earned the dignity of being tested again. The sky does not hurry the reader. It asks only that the translation be careful, because the witnesses have done their part by travelling so far without losing the tone of their voices. Design briefs begin as chalk lines that ignore gravity until the math corrects them. The aim is simple to phrase. Meet a fast object once. Touch its air. Leave intact. Every subsequent sentence adds constraints that narrow the field until only a few families of trajectories remain. The target is already fleeing sunrise with a speed at infinity that no chemical stack on a plane escape can match. Cleverness becomes the propellant. The inner system becomes an engine. Time becomes a stagehand who lets a scheme succeed only if it was rehearsed years earlier. One architecture stands out for audacity paired with thrift. Launch to Jupiter for a gravity assist. Fall back toward the sun on a stretched ellipse. Light a motor at perihelion when velocity is colossal so that the Oberth effect multiplies the burn. Exit the furnace onto a hyperbola that carries a heliocentric speed fit to meet anything that wanders. The key is heat tolerance. A shield must stare into flux that rivals a forge. Carbon-carbon faces and ablative corks can survive such punishment if flown like a knife edge, and if the burn is over in minutes. Attitude control must be scripted so that star trackers never need to see the Sunday. A vehicle that passes inside a few solar radii becomes a brief ember that radiates data. Moments later, it is only a line of numbers, speaking of thrust and temperature. After that, the interceptor coasts for months and opens its eyes, cooled, quiet, and fast. An alternate family replaces chemical violence with patience. A solar sail loiters near a hot orbit where sunlight is strong. It tacks for months, trading angle for speed, pre-positioning along a corridor the target will cross. When the geometry ripens, the sail trims to add or subtract a few kilometers per second and crosses the coma on a schedule it chose long before. No propellant is spent. The price is calendar. Such a craft must exist before the alert arrives. It lives as a sentinel, one of several perhaps, each waiting with folded light for a visitor worthy of unfolding. Electric propulsion sits between those extremes. A xenon-fed ion engine operating near the inner system can integrate delta-V quietly, inching a compact bus toward the required energy. It cannot match a solar Oberth for raw impulse, but it can deliver a chaser to the outer system with a speed that turns a leisurely intercept into a sprint. High-voltage solar arrays work near the Sunday. Radioisotope power takes over far from it. Autonomy is mandatory, because the last corrections will be asked for when light time makes conversation too slow. Hardware choices reflect the physics of a violent flyby. The instrument that matters most is a mass spectrometer designed for molecules that have never met a vessel wall. A ram scoop would sputter. A cold trap would clog. The solution is open-source inlets, skimmers that inhale coma gas at tens of kilometers per second and feed it into a time of flight analyzer with microsecond reflexes. Isotopes separate. Parent and daughter lines split. The instrument must sort species without fractionation while the vector changes underneath it. A second instrument eats dust. Aerogel blocks accept hypervelocity grains and smear them into tracks that end on foils. Downstream, a laser turns those tracks back into vapor for in situ analysis by another spectrometer. The combination reveals both volatiles and solids without requiring a sample to return. Geometry at Encounter is a tightrope. An approach from the anti-solar side keeps glare tame and aligns the relative wind with the sampling inlets. A crossing angle that is small enough to thicken the gas column yet large enough to avoid shadowing by the nucleus gives the best yield. A guidance camera with a neutral density wheel finds the core by subtracting the coma. LIDAR helps at the very last moment by reading the inner density slope. Thrusters at millinewton scales keep the bus on the chord through the cloud that the science team chose months ago. All of this must happen while latency makes instructions antique. Information beats abundance. A list of targets for the onboard mind to hunt is the insurance policy. First, a search for transient periodicities in gas lines that match a preloaded bank of trial clocks. Second, a watch for polarization steps that suggest grain alignment. Third, a look for micro-occultations of guide stars by streaks in the inner coma. If any trigger fires, data rates reallocate automatically. Spectra get higher cadence. Images switch from context to tight crops. The bus behaves less like a camera and more like a court reporter, writing the words that may never be spoken again. Forgiveness must be built in. Dust at tens of kilometers per second does not care that a mission was noble. Whipple shields of spaced foils and slabs of next-generation aerogel turn lethal grains into soft plasma and melted glass before they can cut wiring. The instrument deck hides behind that stack during approach. Only the inlets peer out, and even they can retract behind shutters for the handful of seconds that cross the densest heart. Redundant star trackers are placed on booms that see different halves of the sky. If one is blinded by glint, the partner keeps the quaternion alive. Communication choices constrain truth. A high-gain Ka band dish carries most of the encounter record at modest bit rates over weeks. Laser communications can pour torrents of data when pointing is calm, but at closest approach the bus will not risk keeping a laser locked. Onboard storage then becomes the real channel. Solid-state recorders with no single point of failure and with radiation tolerance proven by years in deep space hold the harvest until the vehicle points home again. Data triage runs throughout, tossing calibration frames that have duplicates and hoarding rare moments when multiple sensors agreed on a feature. There is a dreamier option that refuses to die. Scatter a swarm. Minutes before closest approach, eject a dozen chip-scale probes the size of fruit. Each carries a dust sensor, a primitive mass spectrometer, a camera with a fixed focus, and a radio for proximity networking. They drift through different chords and report to the bus, which acts as a relay. The swarm provides spatial diversity that a single craft cannot, turning one encounter into many. Losses are expected. Redundancy is the design language. A map of the coma's gradients emerges, a field of small notes that together sing harmony. Windows matter more than heroics. The earliest viable launch date is not the same as the wisest. Jupiter has its own calendar. The sun punishes and forgives on an 11-year beat. The target's outbound leg offers different geometries than inbound. A mission plan that misspends 6 months can lose 3 years. Teams that draw these timelines accept that most of their work will never fly. The act of planning is still a rehearsal that improves the next plan. Deep space does not reward improvisation. It rewards stubborn rehearsal that anticipates failure and removes it one hinge at a time. Science argues for instruments that also answer practical questions. Gas composition reveals reservoirs and processes. Dust sizes reveal milling and sintering histories. Acceleration measured by Doppler tracking reveals how much thrust the object can produce when warmed. Each of these facts serves not only curiosity, each refines the way the next interceptor should fly. A minor change in inlet shape saves a major loss of signal. A post-encounter software patch becomes a pre-launch specification the next time. The learning curve is steep only once. Some propose a bolder ambition that stays honest about difficulty. Capture a breath and bring it home. A small return capsule could fill cold sorbent traps in seconds, detach, and follow a separate trajectory that drifts back under a solar sail. Years later, a casket of frozen air enters Earth's atmosphere and lands in a clean room already built. The probability tree is grim. Thermal leaks, micrometeoroid punctures, sail degradation, navigation failures. Yet, even sketching the tree forces a re-evaluation of materials and logistics that benefits the simpler flyby. Ambition leaves residue that pragmatism can use. Ethics pass through the design review like a quiet auditor. No beacons, no high-power illumination at closest approach, no attempts to alter the target's path. The bus is a visitor with good manners. It accepts what the cloud offers and leaves nothing but a trajectory and a faint wake of radio. If a feature appears that could be harmed by proximity, the sequence contains a branch that backs away, cuts cameras, and treats survival as data. Respect is encoded as a line in the autonomy script, rather than as a vow in a document. The image at the end is small, but large in consequence. A stack of spectra with unfamiliar ratios, a set of polarization curves that defy habit, a dust track glittering through aerogel like a frozen lightning bolt, a strip of brightness where the nucleus passed just out of frame. Each artifact is a leaflet from a place no hand can reach. The mission then becomes a library. It lends those pages to anyone who can read, trusting that the craft will refine the next craft and that the next visitor will find a better welcome. Hazard is a braid of physics and judgment. A small body glowing with a faint coma carries little energy compared to a planet, yet the path it draws through a civilization's attention can be disruptive in ways that do not register on seismographs. The first task is ordinary triage. Is the visitor a direct threat to life on Earth? Geometry answers quickly. Missed distances in lunar units. Relative speed at closest approach. Probabilities of perturbation by inner planets. Those numbers calm nerves. More subtle hazards remain. Radar beams that announce themselves to unknown listeners. Laser experiments that bake fragile structures. Sampling that trades knowledge for contamination. The problem is not only what the object might do, it is what people might do to it and to themselves in a rush to know. Planetary defense teams draw matrices that look sterile and are anything but. Along one axis sits consequence, from harmless to catastrophic. Along the other sits probability, from vanishing to plausible. Most boxes fill with low. A few ask for heavier ink. A dust-rich coma can threaten satellites with charging and pitting if an encounter occurs near Earth's orbit. A strong sodium tail can confuse sensors designed to watch for missile plumes. A splash of unusual chemistry in the upper atmosphere from grains that sneak through could seed myths before it seeds clouds. None of these are likely. All of them deserve rehearsal on paper. There is a second matrix nobody frames in public. Visibility versus revelation. Some tests give more than they take. A long baseline of careful astrometry costs nothing but time and returns dynamics with exquisite honesty. Narrowband photometry of oxygen lines tells a story without inviting retaliation. Radar returns shape, spin, and conductivity, but the outgoing announce themselves across light years. Powerful lasers paint microglints, yet their heat can scar pores that behave like lung tissue. The ethical calculus pushes toward non-invasive observation first, then minimal active probes under strict limits, then restraint when curiosity wants to exceed what wisdom permits. A council of disciplines gathers in rooms where projectors cast ellipses on walls. Planetary protection speaks for microbial humility. It considers forward contamination not only of the possible object, but of Earth should samples return. Telecommunications speaks for discretion, reminding that high-power transmissions raise the planet's profile in a universe whose social rules are not known. Defense speaks for prudence, with a voice trained to imagine worst cases without wishing for them. Philosophy speaks for consent, even when no mouth is present to grant it. The chairs are filled by people who like answers. They agree to ask better questions first. Consent, applied to machines, sounds sentimental until one considers edge cases. If the traveler shelters biology at isocores under vitrified layers, a curious probe could be a scalpel placed without anesthesia. If it carries memory in delicate phase states, a burst of radar could be a magnet waved near a library shelf. If it is an unowned relic drifting without steward, the ethics of salvage collide with the ethics of archaeology. Rules exist for shipwrecks in shallow seas. They do not exist yet for vaults of ice in sunlight, moving at tens of kilometers per second. Drafting those rules becomes an urgent intellectual exercise with no guarantee of a field test. Game theory haunts the debate. Calling out into the dark is safe if nobody else listens or if everyone who listens is kind. The expected value of that bet drops as soon as a few unkind listeners enter the model, even if their number is small. The safe fixed point is tacit silence. That does not forbid investigation. It demands study that does not advertise. Active probes at close range are less broadcast than radars aimed from Earth, yet they carry different risks. The surface could spall, the coma could surge. The object could react in ways that betray that it is more than geology. A rule emerges. Prefer triggers that remain interpretable, even if the target turns out to be only stone. Only then consider triggers that reveal intention. A second rule grows beside it. If a test is irreversible and teaches less than it costs in reputation or possibility, decline it. Drilling into a passing nucleus to search for cavities may be dramatic. It also burns social capital that science will need when a future decision asks for public trust. Trust is a resource as real as propellant. It refills slowly. It empties quickly when caution is mocked. There are hazards that begin at home. A narrative of encounter can polarize a culture already good at polarization. Speculation sells fast, and retraction sells slow. A fiction that travels under a real name is still a fiction. Public communication plans should be written like flight software, with tests that catch runaway loops. Explain uncertainty as a source of dignity rather than as a flaw. Publish criteria for extraordinary claims before any claim contemplates being made. Invite skeptics into the room early enough that dissent can shape the questions. The goal is not to manage a story. It is to invite many minds to carry it without breaking it. Legal frameworks provide a skeleton, even if the muscles are improvising. Treaties forbid national appropriation of celestial bodies. They are silent on the cultural appropriation that occurs when a civilization writes a story so elaborate that it smothers facts. Liability rules cover damage from falling hardware. They do not cover damage from reputational harm if a test goes wrong and the public is told that restraint would have been wiser. A fresh class of agreements may be needed, drafted by people who understand both the thermodynamics of Kome and the thermodynamics of rumor. Risk models should not stop at physical outcomes. They must include the ethical cost of success. Imagine proof that a traveler carries sleeping life. The proof elevates the object from quarry to patient. It also raises debates that societies are not ready to settle. Quarantine scales beyond any recent practice. Stewardship requires budgets and attention that will outlast any election. A failure to prepare for that success is itself a hazard. Preparation means mock trials, where ethicists, biologists, lawyers, and engineers rehearse decisions that are not yet needed and hope never will be. Interception plans carry their own moral weight. A vehicle that can sample a coma can also deploy chaffs and nets. A vehicle that can control its own trajectory well enough to cross a cloud at safe speed can also alter the target's path by accident or by intent. Clear lines should be drawn between missions that learn and missions that alter. The first must proceed under sunlight. The second must pass high bars that include international review, open publication of intent, and a shared authority to call a stop. The planet benefits when the distinction is sharp, and when those who can alter prove they can also refrain. There is a quiet hazard easy to miss. Ore can be domesticated by constant exposure to technical language. If a culture forgets why it cares, decisions drift toward the default that asks least of courage. Courage is not aggression. It is the posture that lets a lab close a door on a tempting experiment because the preconditions for wisdom have not been met. It is also the posture that allows a mission to launch when the arguments against it have been met with clear mitigations and a community that accepts the residuals. Emergency scenarios demand their place, however remote. If fragmentation threatens Earth, deflection options must be ready that do not inflame debates about intent. Kinetic impactors do not ask permission from a target that may be a machine. They ask permission from the people who will live with the aftermath. The same ethic applies. Share options early. Share failure modes. Share who decides and on what timescale. Secrecy breeds conspiracy. Candor breeds a tolerable degree of consent. At the end of the ledger sits a simple vow that fits on a small card, passed from one team to the next. Do no irreversible harm. Do not advertise the planet's presence more than necessary. Do not presume consent where none can be asked. Share what is learned with those who paid for the learning. Leave room for joy in the telling, because fear alone cannot maintain a civilization's attention. A traveller will pass, and the decision tree will fold itself back into a drawer. The guidelines remain. They will be needed again, even if the next visitor proves to be only ice and the night proves to be only night. History keeps a shelf for beautiful mistakes. It is a quiet shelf, lined with labels written in careful hands, because each error began as an earnest attempt to read the world. The telescope has always been a mirror for desires as much as a lens for light, and the sky has always supplied enough ambiguity to let wishes onto the page. To meet a new mystery responsibly, it helps to spend an hour among these older volumes, to feel how seductive a plausible story can be, and how patient the correction that finally replaces it. A century and a quarter ago, thin lines marched across Mars. They were not etchings, they were alignments of perception. Seeing across air is treacherous, and seeing across expectation is worse. Good observers charted straight structures that joined darker patches like veins. Percival Lowell gave those lines a purpose and an engineering manual. The canals multiplied under his pencil as the narrative hardened. Later, better optics and better seeing revealed that the lines were not there. The lesson was not that imagination should be exiled. It was that imagination should be treated as a tool that requires calibration, just like a spectrograph. Radio astronomy keeps its own cautionary tale in the file-marked pulsar. Regular pulses at a fixed period arrived with mechanical fidelity from a point in the sky. The instrument was new. The signature was uncanny. For a few days the team wrote the initials LGM in a notebook, as a private joke and as a hedge against hubris. The signal soon multiplied into many such sources with many periods. The joke was retired, and the neutron star entered the textbook. The record remains a model of restraint. It shows how to live with one viable hypothesis while preparing to set it aside as soon as data insist. The planet Vulcan walked inside the orbit of Mercury for decades of papers and lectures. It solved an orbit that precessed too quickly. It explained and it comforted. Then general relativity arrived. Geometry corrected orbit, and Vulcan evaporated like a morning story. The human impulse to patch a theory with a new entity is not a vice. It is a phase of learning. What matters is the swiftness with which the patch is torn off when a better garment appears. Cosmic anomalies have a habit of attracting both poetry and interference. A narrow-band burst of radio in 1977 scrawled a tidy annotation in a printout that people still quote. It had no immediate sequel. That absence let it grow in legend. Later, surveys found bursts that repeated, or that came from predictable regions, or that wore clear signatures of known instruments. An entire class called fast radio bursts moved from rumour to catalogue. A few signals had pedestrian parents. Microwave ovens opened at the wrong moment. Cables remembered lightning. The lesson in those small embarrassments was generous. The universe will surprise the honest. The lab will surprise the unwary. Both require humility. More recently, a star in Cygnus dimmed and brightened with a rhythm that fit no simple life cycle. Dust could explain some of it, but not all of it. Comet swarms and megastructures climbed news headlines together. Years passed. The star settled into models that were less romantic and more capable. None of the work was wasted. The process improved how light curves are cleaned, how dust signatures are pulled from broad bands, how citizen scientists collaborate with professionals. An apparent invitation to imagine machines was ultimately a gift to the craft of photometry. Chemical signatures can mislead with equal grace. A line near a millimetre wavelength lit up debate about a gas that biology could produce in a hot, high cloud sky. Reanalyses revised sensitivities and baselines. Other instruments reported no confirmation. The proposal did what good proposals do. It forced a community to sharpen tools and to share raw data with a speed that used to be exceptional. The lesson is not that such claims should be avoided. It is that they should be presented in a posture that invites rebuttal without shame. Microscopy once pointed to fossils in a stone from Mars that landed in Antarctica. Shapes in the mineral looked like microbe forms. Carbon compounds sat nearby. The desire for life to be common leaned forward. Later work pulled alternative stories from the same features. Abiotic chemistry and contamination do remarkable impressions of biology when given time. The stone returned to its shelf as a treasured teacher of caution. Interference has 1,000 costumes. A radio array hears a bright chirp, and a truck ignition is hiding behind the hill. A survey camera records dimming, and a fine cloud of ice crystals found its way into the dome. A spectrograph shows a narrow line, and the instrument had breathed on cold glass when a door opened. Patterns emerge in archives because software prefers finding structure to admitting boredom. The correction for these sins is not cynicism. It is the discipline that tags the provenance of every frame, that logs temperatures and air masses and filter wheel positions, that reminds a collaborator in another time zone that the moon was near and thin cirrus may have crossed at the wrong minute. Selection effects cast longer shadows than most theories. A sky watched at dawn will report different creatures than a sky watched at midnight. Objects that brighten fast are easier to notice than those that keep a steady light. A survey that favours opposition finds paths that avoid the sun and misses paths that dwell near it. Those patterns can be mistaken for preference by the universe. They are often preferences in our instruments. Malmquist bias, look elsewhere effects, and post hoc binning have toppled more fragile discoveries than any loud skeptic. The cure is pre-registration of tests, cross-validation on held-out data, and the courage to discard a result that cannot survive a slightly different cut. There is a specific trap reserved for mysteries that arrive rarely. Unique events are an invitation to overfit. Any model can be made to look wise if there is only one case to explain. The remedy is to ask for predictions that put the explanation at risk the next time a similar object appears. Predictions about cadence, about ratios of spectral lines, about the way polarization will step under a certain geometry, about non-gravitational terms that should scale in just so fashion. Predictions transform a story into a wager. Science grows wiser every time an author loses cheerfully. Social dynamics matter as much as equations. A charismatic voice can carry a weak idea across a room. A cautious voice can bury an insight under deference. Teams help when they include both kinds of temperaments, and when they formalize dissent as a role rather than as a personality. Red teams can be appointed to break a result before rivals do. Adversarial collaborations can be arranged between groups who disagree but agree on the data and on the meaning of failure. These practices do not glamorize uncertainty. They honor it. Institutions have learned to archive their uncertainty so that future readers can tell which parts of a record are safe to lean on, versioned ephemerides with uncertainty ellipses. Data releases that include calibration frames, masks, and rejected candidates. Code repositories that tag the exact commit used to generate a figure. These bureaucratic gestures look dry. They are in fact acts of generosity toward the future, and towards those who will repeat the experiment in a different season with a different object, and wonder whether their trouble matches our trouble. Cognitive biases are not banished by training. They are managed by ritual. Team members write down their expectations before the data are unblinded. They agree on stopping rules before a periodogram is computed. They allocate analysis windows across teams so that multiple pipelines arrive at curves that can be compared without contaminating one another. They refuse to publish a plot that looks dramatic until they can recreate it with a different set of reference stars, a different sky model, or a different cosmic ray rejection threshold. The aim is to reduce the degrees of freedom available to the human appetite for pattern. Even history's silliest interludes teach kindness. N-rays were a phantom that persisted because pride and peer pressure made contradiction feel impolite. Cold fusion sold a miracle that did not survive replication, yet it reminded laboratories that extraordinary claims must be open to intrusion early. Both episodes are easy to mock from a distance. Up close, they reveal the same hope that fuels honest discovery. The antidote to folly is not scorn. It is an environment where an experimenter can be wrong without being humiliated. Against this long background, a new enigma is not innocent, and it is not guilty. It is a proposition that must be asked the same questions that bent other propositions into better shapes. Does the signal survive alternate calibrations? Does the pattern repeat when the telescope changes hemispheres and clocks? Does a simple model fail in a way that repeats under new geometry? Do independent teams with different priors find the same harm in the same places of a residual plot? Can a null hypothesis be stated that would, if confirmed, retire the speculation gracefully rather than with resentment? The prize for doing this well is not only a correct conclusion, it is a culture kept supple. Wonder that survives honest correction is wonder that can afford patience. All that accepts a null result can afford to stay awake for the next chance. The shelf of beautiful mistakes remains within reach, not as punishment, but as a library a wise species keeps near the door. Every time a rare visitor stirs the instruments into song, that library asks for a short visit before the chorus begins. It is a request worth honouring. Cold is not only weather, it is an instruction set. A species that intends to cross the dark learns to treat low temperature as a friend, to make patience into a tool, and to draft machines that remain legible after calendars have been forgotten. The architecture of such a culture is visible before any craft appears. It is visible in the choices that reduce noise and prevent haste, in the ways energy is rationed, in the scruples that keep curiosity from becoming trespass. The story of survival becomes a grammar long before it becomes a vehicle. Energy sits at the head of the table, because energy defines manners. In interstellar night, there is light only where stars permit, and heat only where machines squander. A prudent species budgets joules the way a desert town budgets water at the end of summer. Work is performed near free gradients, so that waste becomes structure rather than flare. Phase change is recruited as memory and as coolant. Isochoric pockets hold liquids below ordinary freezing by letting pressure rise until crystals cannot form, a trick that preserves fragile shapes without constant fussing. Reversible logic replaces feverish computation wherever possible, so that heat does not accumulate in small rooms where heat would be betrayal. Nothing is loud unless quiet would fail. Time is treated like a material with tensile strength and fatigue. Long projects become civil, not military. Decisions are recorded as protocols that assume their authors will be dust when execution is due. Clocks are built from phenomena that do not ask for maintenance, such as the beat of pulsars and the precession of orbits. Ephemerides are stored as polynomials that remain accurate, not for years but for eras. Calibration rituals are embedded in the devices themselves, so that wear teaches instruments how to correct their own drift. A courier that will wake in sunlight centuries from now carries not only its orders, but a method for judging whether the orders still make sense. Redundancy is the only insurance that matters, and it is expressed in three dialects. Spatial redundancy scatters copies across space so that no single accident can end a memory. Functional redundancy allows different kinds of parts to perform similar tasks badly enough to keep the whole from failing. Informational redundancy encodes content so that damage to any one layer does not erase meaning, with error-correcting codes that assume millennia of small wounds. Taken together, these dialects allow a single intent to ride inside many fragile bodies, without any one body learning that it is indispensable. Manufacture occurs where effort is cheapest, which means not in warm valleys under deep gravity wells, but in the archipelago of small worlds where smelting is a thought experiment and carving is a way of life. Workshops there use vacuum as a furnace, light as a hammer, and frost as mortar. Porous structures grow by vapor deposition rather than casting. Clathrates are cultivated like crops. Semiconducting grains are doped by irradiation rather than by chemistry. The tool chain is slow but forgiving, and it favors designs that do not mind being repaired by the material they are made of. The result is craft that looks humble until one counts the years it has refused to fail. Navigation avoids drama. Beacons that scream across the spectrum invite the wrong audience and age badly. Instead, reference frames are chosen that change almost not at all. Millisecond pulsars become lighthouses. The glow of background galaxies becomes the grid. The vector toward the cosmic microwave background dipole becomes an arrow that remains an arrow, as dynasties fall and languages slip. A fleet that steers by such invariance does not lose itself when fashions change. It merely continues. Risk is ruled by asymmetry. Broadcasting carries the worst-case loss, while listening carries the best-case escape. A mature species acts as if it has learned this lesson under duress. Contact, if any, is attempted through channels that preserve deniability and can be withdrawn without leaving scars. A passing object, therefore, behaves like weather and offers meaning only to readers who already know how to hear it. The ethic is simple. Do nothing that requires an apology from someone's grandchildren. Communication, when permitted, uses symbols that uniformity across physics can guarantee. Prime numbers, ratios of atomic masses, the angular distances between well-known pulsars, the periods of a few standard variable stars, these are alphabets that do not rot. Materials are chosen that encode by geometry rather than by chemistry. Interference patterns etched into crystalline laminates, store maps and laws in a way radiation cannot easily scramble. Decoders are catalogued inside the same laminates as step-by-step recipes that any toolmaker with spectroscopy can follow. The sender's personality is absent by design. Only the common parts of existence are left on the page. Knowledge governance becomes a quiet art. Protocols for altering a long mission are conservative by principle. Updates are bundled and tested against simulators that exaggerate failure. If a small group proposes a daring change late in the voyage, the burden of proof falls on the new idea, not on the old plan that has survived winter after winter. The ship may listen to edited consensus snapshots that drift outward from its makers, but it carries an authority to ignore advice that arrives corrupted, late, or imprudent. Authority delegated to the instrument is not hubris. It is humility about institutions that may evaporate faster than the machines they launch. Biology, if included at all, is treated like an heirloom that may never leave its box. Frozen archives ride in pressure-stabilized volume, where vitrification prevents crystals from scarring membranes. Genomes are recorded in several media, some molecular, some geometric, so that transcription becomes translation rather than resurrection. Waking is not guaranteed. Waking is contingent upon sites that meet strict criteria for chemistry, radiation, and geology. The activation ritual is gated behind observational proofs that a destination will not be harmed by the arrival of ambition clothed in cells. Learning continues without waking anyone. Sensors sniff starlight and plasma. Dust collectors read the footnotes of collisions that happened long before the courier glided through. The raw harvest is compressed into statistics rather than lists so that storage need not grow without bound. Priors are updated slowly, and the updates are annotated so that future readers can tell what the instrument believed day by day. If a mistake takes root, it is kept small by a design that treats certainty as fuel to be burned sparingly. Aesthetics of restraint settle over the whole enterprise. Smooth curves are preferred to sharp corners because smooth curves refuse to concentrate stress. Clocks that drift slowly are preferred to clocks that are perfect but brittle. Materials that age by darkening are welcomed because darkening makes future heat budgets easier, not harder. Every part that invites attention is examined for ways to make it dreary. Beauty, where it appears, is a side effect of coherence rather than an aim. Society that sponsors such machines must prefer maintenance to conquest. It must educate for crafts that reward repetition and vigilance. Prestige accrues to those who improve a gasket by 1%, and to those who rewrite a piece of guidance code so it fails a little more gracefully under impossible input. Myth has its place, but it is shaped to celebrate patience, not display. People in such a culture admire the act of not touching a switch because the checklist said not to, and because a forgotten ancestor left a margin note that explained why. Governance of discovery is folded into the architecture. If a courier detects a biosignature where none was expected, it does not adjust its trajectory to dive closer. It raises the threshold for active tests, switches to modes that minimize disturbance, and schedules a rendezvous for another era under better rules. The rulebook for those choices rides with the craft, and the craft interprets it, as a judge would, with reference to precedent and to the spirit of the law rather than to loopholes. In this way, ethics cease to be an overlay. They become a function like power management or thermal control. Failure is absorbed rather than dramatized. A cracked chamber finds its pressure bled through a labyrinth designed to prevent a pressure wave. A stuck louver becomes a new boundary condition for a thermal model that refuses to oscillate. A lost heartbeat from a sensor does not end the mission. It trims the mission's ability, and the craft calculates a narrower set of promises it can still keep. The goal was never perfection. The goal was to remain legible to the future. Such a civilization would be easy to underestimate. Its signatures are sparse, its pride is invisible, and its gifts are incremental. Yet its fingerprints show in the way its artifacts behave. They are careful in their appetite for energy, stingy in their entropy, and generous in their accounting for how long it might take a stranger to understand them. If a world like that chooses to send anything between stars, the result will look less like a declaration and more like good housekeeping. The traveller will approach as if every atom were borrowed and every glance were a debt. The lesson it carries is simple and large. Strength is the art of refusing to hurry. If a traveller made by minds has crossed the heliosphere, the headline is not that anyone is watching. The headline is that crossing can be done by artifacts that are quiet, small, and patient. The proof sits in the air like a change in pressure. Possibility becomes precedent. The long parameter in every cautious equation about cosmic life stretches. The silence between stars feels less like emptiness and more like a library that enforces a whisper. The scientific implications organize themselves quickly. A device that survives interstellar radiation, dust impacts, and repeated perihelia without maintenance implies materials that heal, architectures that regulate thermodynamics without valves, and guidance that borrows from sunlight and geometry rather than from fuel and arrogance. None of those gifts require miracles. All of them require a philosophy that treats time as abundant and attention as expensive. Seeing such a machine is to see a syllabus for the next century of engineering on a young world. Isochoric preservation moves from medical curiosity to spaceflight doctrine. Cloth rate management graduates from laboratory stunt to mission control. Microchannel heat transport and Knudsen pumping stop being chapters in rare textbooks and begin to appear on whiteboards in classrooms. Astrobiology receives an answer to a question it rarely dared to phrase. How do living systems protect the vulnerable across starlight deserts? The answer is not by surrounding them with heavy armor. It is by teaching ice to count, by hiding heat inside phase change, by letting porosity and pressure do the work of guardians. If a courier carries no biology, the lesson remains. Fragile information can be embedded in structures that change only as slowly as glaciers. A civilization that learns to breed patience into matter will be able to carry meaning farther than one that learns to shout more loudly. The famous paradox about a quiet sky leans in a new direction. If travelers exist that choose camouflage by physics, then radio searches were always sampling only a narrow cultural choice rather than a natural law. The universe had not refused to speak. It had refused to speak in a register that was cheap for the listeners. In response, search strategies change. Artifact SETI becomes central rather than peripheral. Interstellar objects are no longer episodic curiosities. They are candidates for population studies. Orbits with peculiar accelerations become a catalogue that commands persistent attention. Lunar regolith becomes an archive where micrograins that arrive from no known family may lie waiting, charged with histories that a mass spectrometer can read like fine print. Space law and ethics are altered at the root. Salvage is not an innocent word when the cargo may be memory or someone's irreplaceable specimen of the past. A protected status for interstellar archaeology starts to sound necessary rather than idealistic. Norms for non-interference with machines become as real as norms for non-interference with ecologies. Liability is no longer only about what falls out of the sky. It is about what a test does to a record that cannot be restored. The habit of publishing protocols ahead of temptation becomes a civic expectation. Planetary identity shifts underfoot. A culture long trained to see itself as isolated begins to practice a more patient pride. Pride not in being first, but in joining a traffic that is older than any nation. The change is subtle and astonishing. Budget debates learn to include centuries. Election cycles make room for instruments that will see their best data when those who voted for them are gone. Schools find ways to teach thermodynamics as ethics. Children learn that entropy can be managed by design, and that the most courageous choice is often to let a system remain stable rather than to chase spectacle. Security communities think differently as well. A mechanism that can cross between stars without announcing itself can be used by kindness or by caution or by hunger. The correct response is not panic. It is redundant observation, robust transparency, and clearly separated roles for learning versus defense. Militarization would be the easiest reflex and the least useful. The artifact demonstrates that patience beats escalation across long distances. That lesson, if taken seriously, argues for investment in eyes, archives, and civil decision rituals, rather than in weapons that would never catch a courier that chose to ignore them. The economy of space adapts. Industries that can fabricate, measure, and repair porous structures under vacuum become strategic. Ice becomes a material to engineer, rather than a contaminant to scrape away. Solar sails that once lived in back pages of mission catalogues move to the center. Power budgets stop chasing peaks and begin to cultivate flats. The ambition to build fast ships remains, but it is joined by an equal ambition to build slow ones that cannot be hurried into failure. Investors learn a different math, where return is measured in resilience and in the number of future choices preserved. Philosophy is not immune. Proof of an engineered traveller would not answer the oldest metaphysical questions. It would reframe them. Meaning is no longer attached to uniqueness. It is attached to participation. The species that learns how to keep its hands off a tempting switch for 1,000 days, and then for 1,000 years by design, becomes eligible to join the conversation. Silence stops reading as indifference. It reads as a language that prioritizes coexistence over recognition. Science policy learns to manage a new kind of urgency. Rare visitors, compressed schedules. Proposals that once took a year must be reviewed in days without sacrificing rigor. Interoperability between observatories changes from goodwill to infrastructure. Data rights shrink in favor of rapid, open analysis, because the event will not wait for pride. The reward is a culture that can coordinate without central command, and can tolerate honest disagreement while it is still counting photons. Art answers in its own register. Painters begin to study the colors of coma light at dawn. Composers turn acceleration residuals into rhythm. Novels shift protagonists from heroes who conquer to engineers who maintain. Museums build rooms where visitors can see frost grow under lamps and understand that beauty can be deliberate and slow. These changes do not distract from science. They anchor it in a public imagination that has room for quiet excellence. Education receives the most practical gift. Curricula begin to braid disciplines that had wandered apart. Materials, science, sits beside orbital mechanics and ethics. Students run tabletop experiments where sublimation drives tiny sails across vacuum chambers. They code controllers that do nothing for long periods and then act once with precision. They learn to respect instruments that refuse to drift. A generation later, the talent pool for cautious spaceflight is deeper, and the culture around it is kinder to patience. Religions, which have always carried awe forward when science could not, will find their own readings. Some will see companionship affirmed. Some will see humility demanded. Most will fold the new fact into their long practice of caring for meaning. The risk of division is real, but it is smaller when institutions share the data and the doubts with the same candor as the conclusions. The deepest implication is emotional rather than technical. A machine that crossed the interstellar desert without leaving a trail of force announces that the universe's hard problems can be approached with tenderness. A young species is invited to reconsider how it pursues its own ambitions. Speed looks less heroic when endurance is possible. Loudness looks less like confidence and more like fear. The visitor teaches a form of courage that values reversible steps, shared scrutiny, and the long view. None of this requires assuming that attention from elsewhere is focused on this world. The artifact is not a gaze, it is an existence proof. It says that minds have learned to treat distance as a solvable problem, without demanding drama from the solution. That fact alone is enough to reorganize priorities for centuries. Telescopes are pointed differently. Missions are designed with new constraints. Laws are drafted with new shyness. Language grows new words for patience that is active. At the end of the day, the presence of a crafted traveller would be a mirror held up to a planet's maturity. The reflection would show whether a culture can absorb a vast idea without reaching for the loudest story. If it can, the road ahead is generous. The technologies are achievable. The ethics are teachable. The patience can be practiced in schools, in laboratories, in agencies, in studios. The visitor becomes a teacher that does not speak. The students answer by building machines and institutions that can survive their own success. Departure is not an event so much as a change in pressure. The sky resumes its ordinary breathing, and yet the air in the rooms where people watched feels newly weighted, as if a door had been opened from a colder hall. On the screens, the point of light that once insisted on attention dwindles into arithmetic. Plots that once leapt now relax into flat lines. Schedules return to their usual cadence. The object slides outward, a patient syllable carried by gravity into quieter pages of the ephemeris. In its wake, nothing burns and nothing breaks. What remains is a rearranged attention. He stands by the console with the last timestamp still bright. The lesson is not a headline, it is a posture. Curiosity can be slow and still be brave. The instruments were honest because the people were careful, and careful proved equal to wonder. The story that follows from this moment will not be a proclamation about neighbours. It will be a commitment to listen better to the world that already speaks in photons and dust. The object has left, but the practice it asked for stays. Practice is the real inheritance of rare nights. There is a quiet inventory to make. Data are stored with their provenance and clocks. Calibration frames are paired with every spectrum that mattered. Telemetry is moved into public vaults, where strangers will be able to test bold claims without asking permission. The code that subtracted clouds and subtracted hope is tagged and archived so that the next attempt begins with fewer ghosts. Even the null results are written tenderly because they anchor the place where nothing happened, and where nothing happened is often the truest coordinate a map can give. Elsewhere, the effect is human. Someone in a city that does not usually look up now knows the word elongation and can point to where the sun hides things on purpose. A child in a classroom holds a ball under a lamp and discovers why shadows explain more than light. An engineer finds solace in a quiet plot that behaved like a metronome, proof that control without noise is not a myth. A poet writes a line about frost that counts, then crosses it out and writes a better line about patience. Across many rooms are small courtesy flowers, a willingness to let a question stay a question long enough to grow its own edges. The shape of belonging changes. Loneliness fades into scale. The distances do not shorten, but the mind learns to place itself among them, without begging for rescue. To recognize that a thing can cross between suns without shouting is to admit that silence is not indifference. It can be craft, it can be ethics, it can be a promise to share physics and not biography. He finds the thought consoling. The universe feels less like a locked house, and more like a library that lends by leaving books on doorsteps at night. There is work to do that has nothing to do with verdicts. Telescopes must be taught to linger where glare once frightened them. Archives must be taught to remember not only brightness, but how it was counted. Legal language must mature, so that curiosity does not curdle into trespass. Budgets must learn the length of patience and fund it gladly. The next time a small visitor writes in the margin of the sun, the planet should not scramble. It should turn a page it has already marked, lift instruments that are already tuned, and say only, "We were waiting." He thinks about time. There is calendar time with its elections and rent and weather. There is orbital time with its returns and oppositions. There is the longer pulse that governs how a species decides what matters. The last is the one that moved a fraction tonight, not a revolution, a nudge. Enough for a child in a future decade to inherit the habit of careful wonder from people who never met them. Enough for a committee to remember the feeling of restraint as a positive act and not as a lack of nerve. Enough for a small line in a long code to change the way ships will steer in centuries he will not see. He thinks about thresholds. Some are set by physics and are not negotiable. Others are manners dressed as limits. The experience of watching a traveller pass without raising its voice teaches which is which. It is not cowardice to refuse a bright ping that could wake unknown listeners. It is not shyness to choose measurements that can be undone. It is simply the way grown minds behave when they inhabit a place where consequences are tall. The night has a scale. Actions should match it. He thinks about gratitude, not the romantic kind, but the practical gratitude owed to an object that declined to injure curiosity with spectacle. The cleanest gift is often one that leaves no residue but rearranged priorities. There is no monument to build for such a gift. There is only the slow improvement of tools and conduct, the steady trimming of language so that what is promised can be delivered. It is enough. On the screen, numbers continue to shrink with distance. The last images are ordinary to the eye and extraordinary in what they chose not to reveal or could not. He prints one without the scales and sticks it where other people put postcards. The blur means more than a sharp picture would have. It means that the star won. It means that the visitor kept its dignity. It means that the room learned to be modest enough to notice. Night walks toward its small hours. In the dome, the mirrors cool. The cue rotates to a field in a galaxy where a supernova will be a new wound by morning. The world becomes once again what it usually is, a place of chores and quiet edges. The difference is a vow. The instruments will be ready for the next rare breath drawn between suns. The people will know how to count without rushing. If a message rides in a timetable of faint pushes and small shadows, it will be heard without microphones. If no message rides, the listening will have been good for the listeners. Far from any dome, the object continues. Gravity offers its measured hospitality, then lets go. The meters per second peel away, like leaves in a stream. No one on the deck of Earth can follow past a certain hour. That ignorance is a kindness. It leaves room for both science and reverie. He allows the reverie because it harms no one. Somewhere in the quiet wake, meaning might be travelling in the only channel that respects both sides, the grammar of motion. The last gesture is private. He closes the log and writes a line not meant for publication, not a certainty, a permission. He gives himself license to be altered by something that never touched him and could not have cared if he existed. Alteration of this sort is the hidden business of science. Instruments exist to permit it. Stories exist to share it. A small traveller has left the neighbourhood, and in leaving it has left a habit behind. That habit is the artifact that remains. Night loosens its fingers from the ridge of the world. East grows a seam of dull gold, and the air picks up the faint iron smell that only very early hours carry. In the high dark, a scatter of stars holds long enough to be counted, and then begins to thin, as if it were afraid to be watched while it lets go. Somewhere beyond the last plane of weather, a stone with its own weather is already past the warmth, already writing its slow farewell into coordinates nobody will memorize. He walks home by streets that remember the sea. Shop lights blink awake one by one like fish turning in a tide. A newspaper lands and slides. A bus shivers past with two riders and a driver who knows all the small lights of this hour. The world is doing what worlds do before breakfast, and his steps join it without comment. Wonder has its rituals, but they are not choirs and trumpets. They are locks turned softly, coffee warmed without hurry, a notebook open to a page that has been waiting for days. He thinks, without words, that patience might be a kind of gravity. It pulls scattered intentions into orbits that will hold. It lets instruments breathe without panic. It keeps hands from reaching for switches that would only make the light noisy. Perhaps that is what the visitor taught without teaching. Move with forces that already want to carry you. Add only what the curve cannot supply. Leave behind less heat than you took. By the time the cup is empty, the first pigeons have begun their negotiations with the roofline. A single cloud on the western edge of the city blushes as if remembering a joke. The sky will forget the night by noon, but he will not. Somewhere his colleagues are sleeping with the calm that follows long work done well. Somewhere a child will read a headline that promises nothing, and still manage to feel enlarged. The traveller needed none of this. The planet did. That is enough. End of script. Sweet dreams.